For almost the entire history of our species, the human body moved through the world in a slow and constant rhythm. Muscles carried weight across open ground, hips bent and straightened thousands of times a day, feet adjusted to soil, stone, and uneven paths. The body did not remain still for long, because survival rarely allowed stillness. Yet today, in a single quiet day, a human body can remain folded in one position for hours at a time, supported by furniture that did not exist for most of our past. Bones, joints, circulation, and posture were shaped across hundreds of thousands of years in a moving landscape, not in a stationary one. The strange question that follows is simple, but difficult to ignore. If the human body evolved in motion, why do we now spend so much of life sitting? And why was the human body never designed for sitting? For most of the time that humans have existed on Earth, the body rarely remained still. Movement was not exercise, and it was not a deliberate choice. Movement was simply the background condition of being alive. A person woke with the light of morning and began to move almost immediately. The ground beneath the feet might have been dry grass, loose soil, or stone. The distance between one place and another could rarely be crossed without walking. Water required a journey. Food required searching. Even rest often meant changing position, adjusting balance, or shifting weight against the landscape. In such a world, the human body quietly learned a rhythm that repeated day after day, generation after generation. That rhythm was not built around sitting, it was built around motion. If we travel back far enough into the long history of our species, to a time when early humans moved across open land in small groups, the pattern becomes clearer. Survival required awareness of the environment and constant physical engagement with it. A person might walk many kilometers during the course of an ordinary day, sometimes slowly, sometimes with urgency. The body adjusted to slopes, uneven ground, and the subtle shifts of terrain. Muscles worked not in bursts, but in a steady sequence of small contractions that continued for hours. The human frame slowly adapted to this pattern. Bones strengthened in response to repeated pressure from walking. The arches of the feet formed to distribute weight efficiently across long distances. The hips widened in a way that balanced stability with forward movement. Each part of the body learned to cooperate with the others in a coordinated flow that made long periods of motion sustainable. In that distant environment, the idea of remaining seated for hours would have been almost unimaginable, not because sitting itself was impossible. Humans certainly rested. They squatted, knelt, leaned against rocks or lowered themselves briefly to the ground. Yet these moments were temporary pauses within a much larger pattern of movement. Rest rarely became a permanent posture. Even while resting, the body remained active in subtle ways. Balance shifted, legs repositioned, the spine adjusted itself against gravity. These constant adjustments prevented the body from becoming fixed in a single angle for very long. Archaeological and anthropological observations of traditional foraging societies offer a glimpse of how deeply this rhythm once shaped daily life. Many hunter-gatherer groups, even in recent centuries, spent large portions of their waking hours walking, gathering plants, tracking animals, or carrying materials between temporary camps. None of these activities required furniture, and none depended on long stretches of stillness. The landscape itself functioned as the only structure guiding posture and movement. A rock could become a brief seat, a tree trunk could offer support. The ground itself was often the most common resting surface. Yet none of these supports encouraged a person to remain still for very long. The body always returned to motion. Over tens of thousands of years, this pattern left quiet signatures within the anatomy of the human body. The long bones of the legs became strong enough to carry weight efficiently over distance. The spine developed its distinctive curves to stabilize an upright posture while walking. Even the arrangement of muscles in the back and abdomen evolved to help the body remain balanced during motion rather than collapse into prolonged stillness. These features were not designed consciously, of course. They emerged slowly through countless generations of people whose survival depended on their ability to move through the landscape. When we observe the human body today, sitting in chairs, inside rooms, surrounded by stable floors and furniture, it can be easy to forget how recent this stillness truly is. The deep structure of the body still reflects the older world in which our species first learned how to live, a world where standing, walking, bending, and carrying formed the quiet background of every day. The body remembers that world in ways that are not immediately obvious, but the traces remain in our bones, joints, and muscles. Understanding this ancient rhythm is the first step toward recognizing why the modern habit of sitting for long periods feels strangely out of place in a body that evolved in motion. Long before houses, roads, or furniture appeared in human life, the landscape itself determined how the body moved and rested. Early humans did not inhabit enclosed rooms or flat floors. They lived within environments that constantly changed under their feet. The ground could be uneven, sloping gently in one direction and then rising sharply in another. Grasslands stretched for long distances, broken by scattered trees or rocky outcrops. Rivers shifted with the seasons, and paths through the terrain rarely remained fixed. In such surroundings, standing and walking were not simply activities. They were the basic condition of moving through the world. The body had to adapt to surfaces that were rarely smooth or predictable. Each step required subtle adjustments in balance and posture. Ankles rotated slightly to stabilize the foot on uneven soil. Knees absorbed the shifting pressure of the ground. The hips guided the body forward while maintaining stability over long distances. These constant adjustments formed a quiet training process that shaped the human skeleton over thousands of generations. The muscles of the legs and back strengthened through repetition rather than intensity. The spine learned to remain upright while responding to motion rather than resisting it. This dynamic relationship between body and landscape meant that the human form evolved in an environment that encouraged movement at nearly every moment of the day. Early camps and temporary shelters did not interrupt this pattern very much. Archaeological evidence suggests that for most of human history, groups moved frequently in response to seasons, water sources, and the movement of animals. A camp might last only days or weeks before a group continued onward. Tools were carried, repaired, and used outdoors. Food preparation often occurred near fires placed directly on the ground. Even social interaction usually happened while people were engaged in small tasks such as preparing materials, walking between gathering areas, or maintaining tools. Sitting for extended periods rarely fit naturally into this pattern. The body might briefly lower itself to the ground while eating or resting, yet these pauses tended to be short and flexible. Squatting was often more common than sitting. Squatting allowed the hips, knees, and ankles to remain active and balanced. The spine stayed closer to its natural alignment, and the body could rise easily back into motion when needed. Anthropologists observing many traditional societies in recent centuries noticed how frequently this posture appeared in everyday life. People could remain in a squat for extended moments without placing pressure on the back in the same way that modern seated positions often do. This difference in posture reveals something subtle about the environments in which the human body evolved. The landscape did not provide stable surfaces designed for prolonged stillness. There were no uniform heights that supported the legs while the torso remained upright. Natural features such as rocks or fallen logs sometimes offered a place to sit, but they were irregular and rarely comfortable enough to encourage long inactivity. The body therefore continued to shift, stand, walk, and reposition itself naturally. Over many generations, this constant interaction with the environment reinforced the body's ability to remain balanced while upright. The muscles responsible for posture became part of the body's automatic behavior. These muscles did not activate only during exercise. They worked quietly during the simple act of standing, walking, and carrying objects. Even subtle movements of the head and arms required coordination from the muscles along the spine and abdomen. When movement remained a natural part of daily life, these systems functioned without much conscious attention. The landscape itself guided them. This historical relationship between body and terrain reveals an important perspective. The human body did not emerge in a world designed for comfort and stillness. It developed in a world that required constant adaptation to ground, distance, and gravity. The environment itself encouraged the body to remain active. When we imagine early human life across the vast span of prehistory, it becomes easier to understand why stillness never became the dominant posture of the human body. Motion, not sitting, formed the quiet foundation of everyday existence. The rhythm of early human life was shaped not only by the landscape, but also by time. Days began with light and gradually unfolded through a sequence of small movements that rarely stopped for long. The body did not follow a schedule of exercise and rest as many people do today. Instead, Movement appeared naturally throughout the day in quiet and repeated forms. Walking between water sources, gathering plants, carrying firewood, preparing tools, or searching for food were all woven into the ordinary flow of living. Each action might seem small on its own, yet together they formed a pattern that kept the body engaged with the world from morning until evening. In such a rhythm, stillness had a different meaning than it does now. When early humans paused, the pause usually happened within the environment itself. Someone might lean against a tree for a short moment, crouch near a fire, or settle briefly on the ground while sharing food. These moments of rest were simple and temporary. The body rarely settled into a fixed structure that encouraged hours of inactivity. Gravity continued to shape posture, even while resting. The muscles of the back, abdomen, and legs remained lightly engaged to maintain balance and stability. The body was never entirely passive. Anthropological studies of hunter-gatherer communities in the 20th century offer one of the clearest windows into this ancient pattern. Researchers observing groups such as the Hadza of East Africa or the San of Southern Africa noticed that people often alternated naturally between walking, standing, squatting, and brief resting positions throughout the day. Sitting certainly occurred, yet it appeared in shorter intervals and in varied forms rather than in a single fixed posture. The ground, not furniture, supported the body. As a result, the body constantly adjusted its position in subtle ways. These small shifts allowed circulation to continue moving through the muscles and joints without long interruption. From a biological perspective, this pattern of constant low-level movement had important effects on the body. Muscles did not experience long periods of complete inactivity. Instead, they worked at a gentle intensity for much of the day. The calves assisted blood flow back toward the heart during walking. The hips stabilized the body while carrying objects. The spine remained balanced over the pelvis as people moved across uneven terrain. Even when a person stopped briefly, the muscles that supported posture remained quietly active. This continuous engagement helped maintain strength, flexibility, and coordination across the entire body. Evidence of this lifestyle can also be found in the physical remains of early humans. Skeletal studies of prehistoric populations often reveal strong leg bones and well-developed muscle attachment sites along the hips and back. These features suggest that daily life placed consistent mechanical stress on the body through movement and weight-bearing. The body responded to this stress by strengthening the structures that supported upright motion. This process occurred gradually across generations, shaping a human form that functioned efficiently while standing and moving through space. Seen across the deep timeline of human history, the contrast with modern habits becomes clearer. Today, many people spend large portions of the day in environments designed to minimize movement. Floors are flat, distances are short, and furniture supports the body in ways that allow muscles to relax almost completely. While this arrangement offers comfort, it also represents a dramatic change from the conditions under which the human body first evolved. For hundreds of thousands of years, the body expected a world in which movement appeared naturally and frequently. That expectation remains quietly embedded within our anatomy. Understanding this long rhythm of motion helps explain why extended sitting can sometimes feel strangely unfamiliar to the body, even though it has become a common part of modern life. Long before the appearance of cities, buildings, or roads, the environment surrounding early humans played a quiet but powerful role in shaping how the body moved through space. The landscapes where our species evolved were rarely still or predictable. Open savannas stretched across large regions of Africa, interrupted by scattered trees, patches of woodland, and seasonal water sources. The ground was uneven and textured. Grass shifted in the wind, soil hardened during dry seasons and softened after rain, and animal paths created winding routes across the land. In such an environment, the human body developed in constant dialogue with the terrain beneath it. Each step required the body to respond to subtle changes in the ground. Ankles rotated to adjust balance on loose soil or small stones. Knees flexed gently to absorb the shock of uneven surfaces. The hips stabilized the torso while guiding the body forward. None of these movements were dramatic. They happened quietly, thousands of times each day, forming a natural rhythm between body and landscape. Over many generations, this rhythm shaped the physical structure of the human body. Bones became strong where pressure repeated itself, Muscles formed patterns of coordination that allowed efficient walking across long distances. The spine developed its characteristic curves, helping distribute weight while maintaining balance above the pelvis. These features emerged gradually through evolutionary time, responding to the simple but persistent demands of moving through a varied landscape. In this world, long periods of stillness were rare. Water sources could shift across seasons, requiring groups to travel between familiar locations. Edible plants ripened at different times of the year, encouraging people to move through the land while gathering food. Animals followed migration routes that humans sometimes tracked across wide areas. Even daily routines within a temporary camp often involved walking between small activity zones, a fire area, a place for tool repair, a nearby stream, or a patch of vegetation suitable for gathering. The body therefore remained lightly active for much of the day. Movement did not appear as a separate activity that required planning or motivation. It was simply the ordinary way of existing within the landscape. Anthropological observations of traditional hunter-gatherer communities help illuminate how deeply this environmental rhythm influenced daily life. Researchers studying groups such as the Hadza in Tanzania have documented how walking remains one of the most common forms of movement during food gathering and social interaction. Distances may vary from day to day, but the pattern of frequent walking and standing continues throughout waking hours. Even when people pause to rest, the rest often occurs in positions such as squatting or kneeling rather than remaining seated on elevated surfaces. These positions allow the body to remain balanced and ready to return to movement with little effort. The natural landscape itself rarely provided structures that encouraged long inactivity. Rocks, logs, and patches of ground could serve as temporary resting points, but they lacked the consistent shape and support that modern furniture offers. Because of this, the body rarely remained fixed in a single posture for extended periods. Small shifts in balance occurred naturally as people adjusted their position on uneven surfaces. These constant adjustments kept the muscles of the back, legs, and abdomen quietly engaged. Over thousands of generations, this interaction between body and environment became deeply embedded in human biology. The body learned to function most comfortably while upright and mobile. Circulation, posture, and muscle coordination all operated within this context of regular movement. The landscape did not demand stillness. Instead, it encouraged the body to remain responsive to gravity, distance, and terrain. When viewed across the long history of human evolution, the connection between environment and movement becomes clear. The world in which our ancestors lived rarely allowed the body to remain seated for very long. Instead, it gently guided the human form towards standing, walking, bending, and carrying. The landscape itself became the quiet architect of the body's natural rhythm. Across long stretches of human history, the landscape did more than simply surround early humans. It quietly organized how the body distributed effort throughout the day. Distance played an important role in this relationship. Water sources, edible plants, and safe resting places were rarely located within a single small area. Instead, they appeared scattered across the terrain. Moving between them required time and steady walking. A group might travel gradually from one area to another while gathering food along the way, pausing briefly when something useful was found. This pattern created a gentle alternation between movement and short pauses rather than long periods of stillness. The body adapted to this rhythm over countless generations. Walking became the most efficient way to cover ground while conserving energy. The structure of the human foot, with its arch and flexible toes, helped distribute pressure during repeated steps. The Achilles tendon stored and released energy like a small spring, assisting the body as it moved forward. Even the length of the human leg relative to the torso contributed to an efficient stride. These features allowed early humans to travel moderate distances without exhausting the body. Movement became sustainable rather than strenuous. When early humans paused within this environment, the way they rested often reflected the natural surfaces around them. Instead of lowering themselves onto elevated structures, they frequently remained close to the ground. Squatting, kneeling, or sitting directly on the earth allowed the body to maintain balance while staying connected to the terrain. These positions engaged the hips, ankles, and knees in ways that kept joints flexible. The spine remained aligned above the pelvis rather than collapsing backward as it often does in a modern chair. Because these resting positions were less rigid, the body naturally shifted from one posture to another over time. A person might squat while preparing food, kneel briefly near a fire, then stand and walk again after only a short pause. Anthropologists observing traditional societies have noted that these patterns of posture allow the body to remain quietly active even during rest. Small muscles along the spine continue stabilizing the torso. The legs adjust slightly to maintain balance on uneven ground. Circulation flows through the muscles without long interruption. These subtle movements prevent the body from becoming locked into a single position. In contrast, modern seating often encourages a fixed posture where the legs remain bent at a consistent angle and the back leans against a stable surface. The body no longer needs to maintain its own balance in the same way. The landscape also influenced how humans interacted socially and cooperated with one another. Much of daily activity occurred outdoors within shared spaces. People gathered around fires, prepared food together, and exchanged tools or materials while standing or shifting positions around a common area. Conversations happened while walking between locations or while working with the hands. Social life unfolded alongside movement rather than replacing it. The body therefore remained engaged with both the environment and the community through physical presence and motion. Over long periods of evolutionary time, these repeated patterns left quiet marks on the human skeleton. Strong attachment sites for muscles appear along the hips, thighs, and lower back in many prehistoric skeletal remains. These features suggest that daily life involved frequent standing, lifting, and walking. The body responded by reinforcing the structures that supported upright movement. This gradual strengthening occurred not through deliberate training, but through the ordinary demands of living in a landscape that required mobility. When we look at the human body today, it still carries the imprint of this long partnership with the environment. The architecture of the joints, the coordination of muscles, and the balance of the spine all reflect a history in which motion was constant and natural. The terrain shaped the body's expectations. It taught the body to distribute effort across many small movements rather than concentrating pressure in one fixed posture. Understanding this environmental influence helps reveal why the modern habit of prolonged sitting represents such a dramatic departure from the conditions under which the human body first evolved. Over many generations, the quiet partnership between the human body and the landscape shaped more than individual movements. It gradually influenced the deeper patterns of human life across seasons and time. The environment where early humans lived rarely offered permanent stability. Rainfall could change the appearance of a region within weeks. Rivers sometimes shifted their course. Herds of animals moved across wide territories as vegetation changed through the year. Because of these changes, early human groups often adjusted their own movements in response to the rhythms of the land. A camp that felt comfortable for a short period might eventually become less suitable when water sources grew distant or food became scarce. The solution was rarely to remain still and wait. Instead, the group moved. This pattern of seasonal movement reinforced the body's long familiarity with walking and standing. Even when people remained in a particular region, daily tasks still required frequent movement across the surrounding terrain. Someone might walk toward a nearby stream to gather water, return to the camp, then travel again toward an area where edible plants were known to grow. These distances were not necessarily extreme, yet they repeated themselves day after day. Over the course of a lifetime, such small journeys added up to an enormous amount of movement. The body adapted naturally to this rhythm, strengthening the structures that supported repeated walking and standing. In this environment, the ground itself remained the most common surface for rest. Without built structures or furniture, people relied on natural features when they paused. A flat patch of earth, a fallen log, or the base of a tree could offer temporary comfort. Yet none of these surfaces encouraged long periods of stillness. The body continued to respond to gravity and terrain even while resting. When sitting directly on the ground, the hips and spine often required subtle adjustments to maintain balance. A small shift of weight from one side to another helped relieve pressure on the joints. Knees might extend and bend slightly as the body repositioned itself. These gentle adjustments occurred almost automatically, preventing the body from settling into a rigid posture for long. Anthropological observations of present-day foraging societies illustrate how this pattern of rest and movement continues to appear in environments that resemble those of the distant past. Researchers studying groups such as the Hadza and the San have documented how daily life often includes a variety of postures rather than a single prolonged sitting position. People may squat while preparing food, kneel while tending a fire, stand during conversation, and walk short distances between tasks. Even social gatherings around a fire often involve frequent repositioning as individuals adjust their bodies on the ground. These natural shifts maintain circulation and allow muscles to remain lightly active even during quiet moments. Over thousands of years, this pattern shaped the internal systems of the body as well. Circulation benefited from the repeated contraction of muscles during walking and standing. Joints maintain flexibility through frequent changes in angle and position. The spine experienced balance forces as the body alternated between upright movement and varied resting postures. The body rarely experienced the kind of long, uninterrupted stillness that modern environments now make possible. This deep history reveals something subtle but important about the human form. The body evolved within a world that encouraged frequent shifts between motion and rest, rather than prolonged immobility. Movement formed the background of daily life, while rest appeared only in brief and flexible intervals. When viewed across the immense timeline of human evolution, sitting for many hours each day is not simply a modern habit. It represents a profound change in the relationship between the body and the environment. The landscape that once guided human movement has gradually been replaced by structures designed for comfort and stability. Yet the body still carries the memory of the older rhythm in which movement was the natural state of being alive. Long after the landscapes of early human life disappeared from view, in America, quiet traces of that world remain preserved in the ground. Archaeology does not record movement directly, yet the bones and tools left behind by ancient people reveal patterns that speak softly about how the body was used. When researchers examine skeletal remains from prehistoric populations, they often notice a recurring feature. The bones of the legs and hips tend to be dense and strong, showing clear signs of repeated mechanical stress. These stresses are not the result of sudden bursts of effort, but of countless small actions repeated across many years. Walking, carrying materials, bending to gather plants, and rising again from the ground all leave subtle marks where muscles once attached to bone. Over time, these repeated forces shape the skeleton in ways that reflect the daily rhythm of movement. One of the most visible areas where this rhythm appears is the lower body. The femur, the large bone of the upper leg, often shows evidence of strong muscle attachments in prehistoric skeletons. These attachments indicate that the muscles responsible for stabilizing the hips and guiding each step were used regularly and consistently. The tibia, the main bone of the lower leg, also reveals patterns of loading that suggest frequent weight-bearing through walking and standing. When the body moves across uneven ground, these bones absorb pressure and gradually strengthen in response. This process, sometimes described by scientists as bone remodeling, allows the skeleton to adapt to the mechanical demands placed upon it. The more frequently a structure is used in a certain way, the more the body reinforces that structure over time. Archaeologists also examine the joints of prehistoric skeletons for clues about movement patterns. The surfaces of the knee and hip joints often appear smooth but robust, indicating that they experience regular motion rather than long periods of immobility. When joints remain active through a range of movement, the surrounding cartilage and bone surfaces maintain their functional shape. This pattern contrasts with situations in which joints are held in a fixed position for extended periods, which can sometimes lead to different forms of wear. In prehistoric remains, the general picture suggests a body accustomed to regular changes in posture and frequent transitions between standing, walking, and bending. Even the spine preserves evidence of this dynamic use. The vertebrae that form the human backbone are designed to distribute forces while the body remains upright. In many ancient skeletons, the lower vertebrae show adaptations that reflect the repeated compression and release associated with walking and carrying weight. The spine functioned not as a rigid column but as a flexible structure that absorbed motion while keeping the torso balanced over the pelvis. This arrangement worked most efficiently when the body remained active rather than still for long durations. Archaeological discoveries related to tools and living spaces provide additional insight into how movement shaped daily life. Stone tools used for cutting plants or processing animal materials are often found scattered across open areas rather than concentrated in a single stationary location. This distribution suggests that tasks were performed across different parts of the landscape rather than in fixed workstations. A person might prepare materials near a water source, move elsewhere to continue shaping a tool, and later return to a fire to cook or share food. The body therefore shifted continually between positions and locations throughout the day. These archaeological patterns help reconstruct a world in which movement formed the quiet background of human activity. The body was rarely confined to a single place or posture. Instead, it remained engaged with the surrounding environment through constant adjustments in balance and motion. Each step, each bend toward the ground, and each rise back to standing reinforced the physical structures that supported upright life. When researchers place these pieces of evidence together, a clear picture begins to emerge. The human body did not develop in a context of prolonged sitting. The skeletal record instead reflects a long history of bodies in motion, responding to gravity and terrain with repeated cycles of movement. Through bones preserved across thousands of years, the past reveals a simple but powerful message. The human form grew strong in a world where standing and walking were ordinary, everyday conditions of life. When archaeologists attempt to understand how ancient people lived, they often begin with small details preserved in bone. These details are not dramatic. They appear as slight ridges, thickened areas, or subtle changes in shape where muscles once attached to the skeleton. Yet together they form a quiet record of how the body moved during life. Every muscle pulls on bone when it contracts, and when this pulling happens repeatedly over many years, the bone slowly adapts to the force. The stronger and more frequently a muscle is used, the clearer its attachment point becomes on the skeleton. Through this process, the human body leaves behind a physical memory of its daily habits. In prehistoric skeletons, these attachment sites often appear particularly well developed in the lower body. The muscles that control the hips, thighs, and calves show strong evidence of repeated activity. These muscles play a central role in walking, balancing, and stabilizing the body while upright. Their prominence in ancient remains suggests that movement across the landscape was not occasional but routine. Each step placed pressure through the legs into the ground, and each step required coordinated muscle activity to maintain balance. Over many years, the skeleton responded by reinforcing the structures that supported this repeated motion. The feet themselves also reveal clues about how the body interacted with the ground. The bones of the foot form a complex structure designed to distribute weight efficiently while walking. The arch of the foot acts as a natural spring, absorbing impact and returning energy during each stride. In many prehistoric remains, the bones associated with this arch appear strong and well supported, indicating frequent use under natural walking conditions. The toes, particularly the big toe, align forward in a way that assists propulsion during movement. These features highlight how the human foot evolved primarily for locomotion, rather than for remaining stationary on flat surfaces. Even the wear patterns on ancient teeth can offer indirect hints about daily activity. Food preparation often required physical effort, such as grinding plant materials or processing tough fibers. These tasks typically took place close to the ground and involved repeated bending, squatting, or kneeling. The body, therefore, alternated between upright movement and ground-level work throughout the day. Such activities encouraged flexibility in the hips and knees, allowing the body to shift smoothly between postures rather than remaining fixed in a single seated position. Archaeological excavations of ancient living sites further support this image of constant movement. Instead of evidence for fixed seating areas or elevated furniture, most prehistoric camps reveal open activity zones arranged around simple features such as fire pits. Tools, fragments of animal bone, and plant remains often appear scattered across these spaces rather than concentrated around a single stationary location. This pattern suggests that people moved frequently while performing tasks, adjusting their position in response to work, conversation, and the natural environment. Movement, in this context, was woven quietly into the fabric of everyday life. The human body adapted to this lifestyle in ways that are still visible today. The alignment of the hips above the legs supports efficient standing posture. The spine balances the upper body while allowing flexibility during walking and bending. The muscles of the lower back and abdomen coordinate to stabilize the torso during motion. These features form an integrated system that functions best when the body alternates between movement and brief periods of rest. Long stretches of immobility rarely appear in the archaeological record of early human life. Instead, the evidence consistently points toward bodies that remained active across the landscape. The skeleton therefore serves as a silent witness to a world where the human body interacted constantly with gravity and terrain. Through these preserved structures, the past reveals a lifestyle defined not by stillness, but by the steady rhythm of upright movement. When archaeologists bring together the scattered fragments of prehistoric life, a quiet picture of daily activity begins to appear. This picture does not show a world organized around stillness. Instead, it reveals bodies that moved continually within their surroundings. Camps were rarely permanent structures. They were temporary spaces that people occupied for a short time, before shifting again in response to seasons, water, and food. Because of this, the physical arrangement of daily life encouraged movement across small distances many times throughout the day. Someone might walk to collect water, return to a fire where food was prepared, move again to shape a stone tool, and later travel a short distance to gather plants or wood. Each action required the body to stand, bend, walk, and rise repeatedly. These small cycles of movement accumulated quietly over time. Archaeological sites often preserve traces of these activity patterns in the distribution of objects. Instead of finding evidence for a single fixed work area, researchers frequently observe clusters of tools and materials spread across different parts of a campsite. Stone flakes from tool making might appear in one area, while animal bones processed for food appear in another. The spaces between these clusters suggest that people moved frequently as they worked. Tasks unfolded across the landscape rather than remaining confined to a single stationary location. In such an environment, the body naturally alternated between positions, standing while shaping tools, walking between work areas, and crouching near a fire formed a continuous sequence of movement. Even social interaction likely followed this pattern. Conversations occurred while hands remained busy and bodies adjusted to the ground beneath them. The absence of fixed furniture meant that posture changed naturally with the task at hand. A person preparing food near the ground might squat or kneel. Someone watching the surrounding area might remain upright while standing. Others might shift their weight while sitting briefly on the ground before rising again. None of these postures locked the body into a rigid structure for very long. Instead, the body moved fluidly between them, guided by the immediate needs of the moment. The skeletal remains recovered from prehistoric populations reinforce this interpretation. Many ancient skeletons display a balanced development of the muscles associated with walking, lifting, and maintaining upright posture. These features suggest that the body was used across a wide range of positions rather than repeatedly returning to a single seated posture. The hips and lower back in particular often show strong attachment sites where muscles responsible for stabilizing the torso during movement once connected to bone. Such patterns indicate that the body regularly supported its own weight against gravity while standing and walking. Another subtle clue appears in the absence of structures that would encourage long sitting. In prehistoric contexts, archaeologists rarely find physical evidence for objects designed specifically for prolonged seated comfort. Instead, living spaces revolve around simple features such as hearths, temporary shelters, and open ground surfaces. The human body therefore interacted directly with the natural terrain rather than with constructed furniture. This direct contact with the environment encouraged frequent shifts in posture and balance. Even during quiet moments, the body remained lightly engaged with gravity and the ground. When these archaeological observations are placed alongside the biological features of the human skeleton, a consistent message emerges. For the overwhelming majority of human history, daily life unfolded in motion. Movement did not require planning, equipment, or designated exercise time. It appeared naturally through the tasks necessary for survival. Standing, walking, bending, and carrying formed the ordinary rhythm of life across generations. The body evolved within this rhythm, gradually adapting its bones, joints, and muscles to support an active relationship with the landscape. Through the silent testimony of archaeological evidence, the past reminds us that the human body grew strong in a world where stillness was brief and movement was constant. Hidden beneath the surface of the human body is a structure that quietly carries the weight of nearly every movement we make. The spine rises from the pelvis to the base of the skull, forming a flexible column of vertebrae that supports the upper body, while allowing the head and torso to move in balance. At first glance, it may appear like a simple vertical support, yet its design reveals something far more complex. The human spine is not straight. Instead, it forms a gentle sequence of curves that shift direction along its length. These curves distribute pressure as the body stands upright, helping the skeleton remain stable while gravity pulls downward through the torso. Over hundreds of thousands of years, this structure evolved in a body that moved frequently across the ground, rather than remaining fixed in one position. When a person walks, each step sends small forces upward from the feet into the skeleton. The spine responds to these forces through its curved shape and flexible discs that separate each vertebra. These discs act like cushions, compressing slightly under pressure and then returning to their original form as the body continues forward. In this way, the spine functions less like a rigid pole and more like a dynamic system that absorbs motion while maintaining balance. The muscles surrounding the spine participate in this process as well. Deep muscles along the back and abdomen contract gently during walking to stabilize the torso and prevent excessive swaying. This constant coordination allows the body to remain upright without becoming stiff. Movement therefore becomes part of the spine's natural working condition. In an environment where people walked across uneven terrain and shifted posture frequently, the spine rarely remained under the same type of pressure for long. The forces placed upon it changed subtly with each step, bend, or adjustment of balance. Anthropologists studying the evolution of the human skeleton often point to the lower portion of the spine as an important adaptation for upright movement. The lumbar region, located above the pelvis, contains vertebrae that are larger and more robust than those higher in the back. These vertebrae support much of the weight of the upper body while allowing flexibility during walking and bending. Their size reflects the repeated loads placed on them when the body stands and moves through space. This design works efficiently when the body alternates between motion and brief rest, allowing pressure to shift across the spine rather than concentrating in a single location. The relationship between the spine and the pelvis further illustrates how the human body evolved for upright movement. The pelvis forms a stable base that supports the spine above the legs. When a person stands or walks, the pelvis tilts slightly forward, allowing the natural curve of the lower spine to maintain balance. This alignment keeps the center of gravity positioned above the hips and feet, making upright posture relatively effortless. The body therefore distributes its weight through a vertical structure that functions best while gently adjusting to motion. In contrast, when the body remains seated for long periods, the orientation of the pelvis often changes. Instead of tilting slightly forward, the pelvis tends to rotate backward as the body settles into a chair. This shift alters the natural curve of the lower spine, placing pressure on structures that originally evolved to support dynamic movement. The discs between vertebrae experience forces from different angles, and the muscles that normally stabilize the spine during walking may become less active. While the body can tolerate this posture for limited periods, it represents a condition that differs from the environment in which the spine first evolved. Seen through the lens of evolution, the human spine reflects a long history of bodies moving through landscapes rather than remaining still within constructed spaces. Its curves, discs, and supporting muscles form a coordinated system designed to manage motion, balance, and shifting pressure. The spine does not simply hold the body upright. It participates in every step, bend, and adjustment that occurs while the body interacts with the world. This deeper understanding of the spine reveals why prolonged stillness can sometimes feel uncomfortable in a structure shaped by countless generations of movement. When the body sits, the spine does not simply rest. It changes the way it carries weight. In standing, gravity travels down through the skull, the vertebrae, and into the pelvis and legs. The natural curves of the spine help spread that load, and the small muscles around the trunk keep the torso balanced with gentle, continuous work. Walking adds a second layer. The load shifts with every step, and the discs between the vertebrae experience a pattern of compression and release. Over a lifetime of regular movement, this changing pressure helps the spine stay resilient, because no single area is asked to bear the same force, in the same angle, for very long. Sitting alters that old pattern in a quiet but significant way. Most people, when seated, allow the pelvis to roll backward. This is a natural response to being supported by a chair. The thighs are held level, the hips remain flexed, and the body no longer needs to balance itself in the same way. As the pelvis tilts back, the lower curve of the spine often flattens. The torso may then lean forward toward a screen or a table, or lean backward into a backrest. Either way, the spine begins to carry weight under conditions it rarely faced for most of human history. Long duration, fixed angles, and reduced muscular participation. The discs can tolerate compression, but they were shaped by a world in which compression was interrupted by movement. When the body remains seated for hours, the interruption is smaller. The spine receives less variety in how forces move through it. Some tissues are pressed in a consistent direction, while other tissues remain lengthened for a long time. At the same time, the muscles that would normally help stabilize the trunk during standing and walking can become quieter. A chair performs part of their job. Over days and months, this can subtly change how the body distributes effort, because the nervous system tends to preserve energy by using support when it is available. This does not mean sitting automatically creates injury. It means sitting changes the conditions the spine is working under. The evolutionary story matters here because it helps explain why the change can feel uncomfortable even without clear damage. The spine evolved as a moving structure in a moving life. Its curves are part of a system that expects shifting loads, frequent posture changes, and regular use of the hips and legs to share the work of supporting the torso. When the lower body becomes still, the trunk often becomes the main place where stress gathers. This can be felt most clearly in the lower back, where the spine meets the pelvis. That junction is designed to be strong and flexible, but it depends on the pelvis maintaining a stable position. In long sitting, the pelvis is held in one position for too long. Another quiet effect of sitting is that it reduces the spine's normal need to balance the head over the body. In standing, tiny adjustments in the neck and upper back keep the gaze level. In sitting, especially when leaning forward, the head can drift ahead of the torso. The body can compensate, but compensation often means more sustained tension in certain muscles and less variety in movement. Over time, stiffness becomes more common, not because the spine has forgotten how to work, but because it is being asked to work in a narrower range. Seen across the long arc of human history, the chair invites the spine into stillness that is deeper than the body's older rhythms. The most important idea is not that sitting is unnatural in a dramatic sense. It is that the spine was shaped to thrive on change. Small shifts, frequent rises, and gentle motion, while modern sitting often removes those changes for hours at a time. The spine does not work alone. Every movement of the back is quietly supported by a network of muscles that surround the trunk and connect the upper body to the pelvis and legs. These muscles rarely attract attention because their role is subtle. They do not produce large visible movements most of the time. Instead, they stabilize the body so that other parts of the skeleton can move smoothly. When a person stands upright, dozens of small muscles along the spine, abdomen, and hips coordinate to keep the torso balanced over the legs. Each muscle contributes a small amount of effort, adjusting continuously as the body shifts its weight. In a life that includes frequent walking and standing, this coordination becomes almost automatic. The muscles engage and release in gentle cycles as the body interacts with gravity and the ground. One of the most important groups in this system lies deep along the spine itself. These muscles run between the vertebrae and help control the fine adjustments of posture. They respond instantly when the body leans slightly forward or backward. When a person walks, these muscles stabilize the spine so that the torso remains balanced above the moving legs. Without this support, the body would struggle to maintain an upright position. Their activity is usually quiet and continuous rather than intense. In an environment shaped by regular movement, these muscles remain active for much of the day. Another group of muscles works from the front of the body to complement this support. The abdominal muscles connect the rib cage to the pelvis and help control how the spine bends and rotates. During walking, these muscles coordinate with the back muscles to stabilize the trunk while the legs move forward. This partnership between front and back muscles creates a balanced structure that allows the spine to remain flexible without collapsing. The body therefore distributes effort across many small muscles rather than relying on a single structure to carry the entire load. The hips also contribute to this stabilizing system. Large muscles surrounding the pelvis guide the movement of the legs and help maintain alignment between the lower body and the spine. When a person stands or walks, these muscles share the responsibility of supporting body weight. The pelvis acts as a bridge between the legs and the spine, allowing forces from the ground to travel upward through the skeleton in a controlled way. Because these muscles are regularly engaged during standing and walking, they help maintain strength and coordination throughout the trunk. When the body remains seated for extended periods, the pattern of muscular activity changes. The chair supports part of the body's weight, reducing the need for many stabilizing muscles to remain active. The hips stay flexed, and the legs no longer participate in supporting the torso. As a result, some of the muscles that normally maintain posture may reduce their activity. Over time, this shift can influence how the body distributes effort when returning to standing or walking. The muscles are still capable of performing their original roles, but they may not be engaged as frequently as they were in environments shaped by regular movement. Anthropological observations of societies that maintain more traditional movement patterns reveal an interesting contrast. People who spend much of their day standing, walking, or working close to the ground often display strong coordination between the muscles of the back, abdomen, and hips. Their posture tends to remain balanced without relying on external support. Even during rest, their bodies often remain lightly engaged through positions such as squatting or kneeling. These postures allow the stabilizing muscles to remain active while the body relaxes. Over the immense span of human history, the muscular system of the trunk evolved alongside the spine to support a body that remained upright and mobile. The muscles surrounding the spine do more than produce movement. They maintain balance, distribute pressure, and respond to gravity in ways that keep the body stable during everyday activity. This system functions most naturally when the body alternates between standing, walking, bending, and resting in varied postures. When the body spends long periods supported by chairs and flat surfaces, the quiet partnership between these muscles and the spine changes. The body remains capable of movement, yet the natural rhythm of muscular engagement becomes less frequent. Understanding this partnership between spine and muscle helps reveal another reason why the human body developed within a world of movement rather than prolonged stillness. Beneath the surface of every step lies a quiet coordination. Between the hips and the knees, these joints form the central mechanism that allows the human body to move across the ground while remaining balanced above the legs. When we imagine walking, it can seem like a simple act, yet the process requires a carefully arranged system of bones, muscles, and ligaments working together in rhythm. The hips guide the direction of movement, while the knees absorb and redistribute the forces created when the foot meets the ground. Over long stretches of evolutionary time, this partnership developed in bodies that traveled regularly through open landscapes rather than remaining in a single place. The structure of the hip joint reveals much about this history. The hip is one of the largest and most stable joints in the human body. It forms where the rounded head of the femur fits into the cup-shaped socket of the pelvis. This arrangement allows the leg to move in multiple directions while still supporting the weight of the torso above it. In an upright body, the hips must carry a significant portion of the body's load. When a person stands, gravity presses downward through the spine into the pelvis and then through the hip joints into the legs. The shape and strength of the hip socket help distribute this force so that the body can remain balanced without excessive strain on any single structure. Walking introduces a new layer of complexity to this system. Each step requires the hips to stabilize the body, while one leg moves forward and the other supports the body's weight. The muscles surrounding the hips contract in subtle patterns that prevent the pelvis from tilting too far from side to side. This stabilization allows the upper body to remain relatively steady even as the legs alternate in motion. Without this quiet work from the hips, walking would become inefficient and unstable. The knees complement this function by acting as flexible hinges that respond to the forces of each step. When the foot contacts the ground, the knee bends slightly, allowing the body to absorb the impact of movement. This bending distributes the load across the joint rather than transmitting it directly upward into the spine. As the body moves forward, the knee straightens again, helping propel the body into the next step. This repeated cycle of bending and straightening occurs thousands of times each day in a life that includes regular walking. The joint surfaces of the knee are therefore built to tolerate frequent motion rather than long periods locked at a single angle. Anthropological research into human locomotion highlights how unusual this walking ability is among mammals. Humans move efficiently on two legs for extended distances. This form of locomotion, known as bipedalism, emerged early in the evolutionary history of our lineage. Fossil evidence from early hominin species shows changes in the pelvis, femur, and knee joint that reflect this adaptation to upright walking. These anatomical changes allowed the body to conserve energy while traveling across open terrain. The hips became broader and more stable, while the femur angled inward toward the knee to help position the body's center of gravity above the feet. These adjustments created a system that works best when the body alternates continuously between supporting weight and moving forward. The mechanical design of the hips and knees therefore reflects a body that evolved through motion rather than stillness. These joints function most effectively when they are allowed to move through their full range repeatedly. When the body stands, walks, bends, or rises from the ground, the hips and knees distribute forces throughout the lower body in ways that protect the spine and maintain balance. Over the long timeline of human history, this pattern of movement formed the foundation of daily life. The human skeleton gradually adapted to support upright walking as a normal condition of existence. Through this lens, the hips and knees reveal another part of the story of how the human body developed within a moving world. The mechanics of the hips and knees become clearer when we look closely at what happens during a single step. Walking appears smooth and continuous from the outside, yet internally the body moves through a sequence of precise adjustments. As one foot lifts from the ground, the other leg becomes responsible for supporting the entire weight of the body. In that brief moment, the hip of the supporting leg must stabilize the pelvis so that the torso remains balanced. Several muscles surrounding the hip joint contract gently to prevent the pelvis from tilting downward on the side of the lifted leg. This action may seem small, yet it repeats with every step taken during the day. Over thousands of steps, the hips quietly perform the work that keeps the body upright while the legs alternate in motion. At the same time, the knee of the supporting leg responds to the downward pressure of body weight. Rather than remaining rigid, the knee bends slightly to absorb the force created when the foot touches the ground. This bending helps distribute pressure across the joint surfaces and surrounding tissues. As the body moves forward, the knee gradually straightens again, allowing the leg to extend and assist in pushing the body into the next stride. The process is both stable and flexible. Stability allows the skeleton to support weight, while flexibility prevents excessive stress from concentrating in a single place. When these movements occur repeatedly over many years, the bones and ligaments of the knee adapt to accommodate this pattern of motion. The design of the femur contributes significantly to this balance between stability and movement. The upper portion of the femur connects to the pelvis at the hip joint, while the lower end meets the tibia at the knee. Between these 2 points, the femur angles slightly inward toward the center of the body. This inward angle positions the knees closer to the body's center of gravity, helping maintain balance during walking. Without this alignment, the body would sway more dramatically from side to side with each step, requiring additional energy to remain upright. This anatomical feature therefore improves efficiency during long periods of movement. Another important component of this system lies in the ligaments that stabilize the knee. These strong bands of connective tissue prevent excessive movement within the joint, while still allowing the bending and straightening necessary for walking. The cruciate ligaments inside the knee guide how the femur and tibia move relative to one another during each step. Their arrangement allows the knee to function like a controlled hinge rather than a loose connection between bones. This stability becomes particularly important when the body travels across uneven ground, where the knee must respond quickly to changes in terrain. Over the course of human evolution, these structures developed in a body that regularly moved across varied landscapes. Walking across grass, soil, and stone required the hips and knees to coordinate with subtle adjustments in angle and pressure. The joints were rarely asked to remain still for long durations. Instead, they moved through small ranges repeatedly, distributing mechanical stress across the joint surfaces in changing patterns. This variability allowed tissues within the joint to experience cycles of loading and release rather than continuous compression. When the body remains seated for extended periods, the hips and knees often remain bent at nearly the same angle for a long time. This posture limits the natural cycles of motion that normally occur during walking and standing. The joints themselves are still capable of movement, but they spend less time traveling through the full range of motion that once characterized daily activity. Over time, this reduction in movement can influence how comfortable the joints feel when returning to motion after long stillness. Through the long history of human evolution, the hips and knees developed as parts of a system designed for repeated cycles of support and movement. Each step allowed these joints to absorb force, maintain balance, and guide the body forward across the landscape. Their structure reflects a body that expected motion to be part of ordinary life, rather than an occasional activity separated from rest. When the hips and knees move together during walking, they create a rhythm that spreads force throughout the lower body. This rhythm is quiet and steady. Each step begins when the foot contacts the ground and the body's weight shifts onto that leg. The knee bends slightly, and the hip adjusts to keep the pelvis stable above the supporting foot. A moment later, the body moves forward, the knee straightens, and the opposite leg begins its own movement through the air. This alternating pattern repeats again and again, sometimes thousands of times in a single day when walking is part of ordinary life. What makes this system remarkable is the way it distributes pressure rather than concentrating it. The hips guide direction and stability, the knees absorb and release force, and the ankles adapt to the ground beneath the feet. Because each joint contributes a small part of the effort, no single structure carries the entire load. The body moves forward smoothly, with energy flowing through the skeleton and muscles in coordinated cycles. In evolutionary terms, this pattern allowed early humans to travel long distances without exhausting the joints. Walking became an efficient and sustainable form of movement. Anthropologists studying traditional foraging communities have observed how frequently this pattern appears in daily life when people move through the environment to gather food, water, and materials. Walking may occur in many short segments throughout the day rather than in one long journey. Someone might travel a short distance to collect plants, return to a central area, then walk again toward another location. These repeated movements reinforce the natural coordination between hips and knees. Even when people pause to rest, the body soon returns to motion, allowing the joints to continue cycling through their natural ranges. Over many years, this repeated movement helps maintain the strength and flexibility of the tissues that surround the joints. Cartilage within the knee receives nourishment from the movement of joint fluid as the knee bends and straightens. Ligaments maintain their resilience when they experience gentle tension and release during walking. The muscles around the hips remain engaged in maintaining balance and guiding the legs forward. This constant but moderate activity keeps the entire system functioning smoothly. The body therefore depends on movement not only for locomotion but also for maintaining the health of the joints themselves. In contrast, long periods of sitting change how these joints experience pressure. When the body sits in a chair, the hips remain flexed and the knees stay bent at roughly the same angle. Instead of moving through cycles of bending and straightening, the joints remain relatively fixed. The muscles that would normally stabilize the hips during standing become less active because the chair supports the body's weight. Over time, the absence of regular motion can make the joints feel stiff when movement begins again. This stiffness does not necessarily indicate damage. Rather, it reflects the difference between a joint designed for frequent movement and a posture that holds the joint still for extended periods. From an evolutionary perspective, the hips and knees were shaped in a world where walking was woven into nearly every aspect of daily life. The landscape required people to move repeatedly across distances both short and long. Each step reinforced the mechanical partnership between these joints, allowing the body to remain balanced and efficient while upright. The skeleton gradually adapted to this pattern of motion, strengthening the structures that supported the repeated cycles of walking. Through this long history, the hips and knees became central to the way the human body interacts with gravity and the ground. Their design reflects a body accustomed to motion rather than stillness, a body whose joints expect to move regularly as part of ordinary life. Beneath the visible movements of walking and standing, another system of the body quietly responds to motion. This system is the circulation of blood. Every second, the heart pushes blood through an intricate network of vessels that reach nearly every tissue in the body. Oxygen, nutrients, and chemical signals travel through these vessels, supporting the activity of muscles and organs. Yet the heart does not work alone in this process. The movement of the body itself plays an important role in helping blood return from the lower parts of the body back toward the heart. In a life shaped by regular walking and standing, the muscles of the legs act as a gentle support system for circulation. Each time the muscles of the calves contract during a step, they compress the veins that pass through the lower leg. This compression pushes blood upward toward the heart, Small valves inside the veins prevent the blood from flowing backward, allowing it to move gradually in one direction. As the muscle relaxes, the vein refills with blood from below, preparing for the next contraction. Through this repeated cycle of contraction and relaxation, the muscles assist the circulation of blood during movement. Scientists sometimes describe this mechanism as a muscular pump. Though it operates quietly and automatically whenever the body walks or shifts weight while standing, this process becomes particularly important in the lower body because gravity naturally pulls blood downward. Without some form of assistance, blood returning from the legs would have to rely entirely on the pumping force of the heart. Over the long span of human evolution, frequent movement allowed the muscles of the legs to provide this assistance regularly. Walking across the landscape activated the calf muscles thousands of times each day, helping blood travel upward through the veins. Even small shifts of posture while standing could stimulate this process by gently engaging the muscles that support balance. In an environment where movement occurred throughout daily life, circulation and motion formed a quiet partnership. Anthropological observations of people living in traditional foraging societies offer a glimpse into how this relationship once functioned. Many individuals spend large portions of their waking hours walking between gathering areas, standing during food preparation, or moving short distances between tasks. These activities may not appear intense, yet they involve repeated contractions of the muscles that assist circulation. The body therefore maintains a steady rhythm of blood movement supported by physical activity distributed across the day. Even during rest, postures such as squatting or kneeling keep the muscles of the legs lightly engaged rather than completely inactive. The human body appears well adapted to this pattern. The structure of the veins in the legs reflects the expectation that blood will regularly travel upward against gravity with the help of muscle activity. Valves within these veins are arranged to guide blood step by step toward the heart. When the body alternates between movement and brief rest, these valves open and close in coordination with the muscular contractions around them. The result is a steady circulation that supports the tissues of the legs while maintaining balance in the entire cardiovascular system. When the body remains seated for extended periods, this partnership between movement and circulation changes. The legs remain relatively still, and the muscles that normally assist the upward flow of blood are used less frequently. Blood can move more slowly through the veins of the lower body when the muscular pump is inactive. The circulatory system continues to function, but it does so under conditions different from those that shaped its development across human history. Over the immense timeline of human evolution, circulation evolved in a body that rarely stayed still for long. Walking, standing, and shifting posture repeatedly throughout the day supported the movement of blood through the lower body. The circulatory system therefore developed within an environment where motion was a constant companion to the beating of the heart. Circulation in the human body depends on a balance between the steady pumping of the heart and the quiet assistance provided by movement. While the heart pushes blood outward through the arteries with strong pressure, the return journey through the veins occurs under much gentler conditions. The walls of veins are thinner and contain less muscular structure than arteries. Because of this, the body relies on additional mechanisms to help blood move upward from the legs back toward the chest. One of the most important of these mechanisms is the repeated contraction of muscles in the lower body during everyday activity. When a person walks, the muscles of the calves and thighs tighten and relax in a rhythmic pattern. Each contraction squeezes the veins that pass through these muscles, pushing blood upward. Inside the veins, small valves open to allow blood to move toward the heart and close to prevent it from falling backward under the influence of gravity. With each step, blood advances a small distance upward through the leg. Over time, the accumulation of many small steps allows circulation to continue smoothly through the lower body. This system functions most effectively when the muscles are activated frequently, even at low levels of intensity. Standing also contributes to this process in subtle ways. The body rarely remains perfectly still while standing upright. Small adjustments of balance occur constantly as the nervous system keeps the body aligned above the feet. These adjustments activate muscles in the legs and hips, creating gentle contractions that continue to assist the movement of blood through the veins. Even shifting weight from one foot to the other stimulates circulation by engaging the muscles that surround the veins. In a life that includes regular walking, standing, and repositioning throughout the day, These small muscular actions repeat continuously. The circulatory system evolved within this pattern of activity. Anthropological observations of hunter-gatherer populations illustrate how this partnership between movement and circulation appears in daily life. When people gather food, carry materials, or walk between areas of activity, the muscles of the lower body remain active for much of the day. These movements may not be strenuous, yet they occur frequently enough to support the steady return of blood from the legs to the heart. The body therefore maintains circulation not only through the heartbeat but also through the natural rhythm of movement distributed across ordinary tasks. When the body remains seated for extended periods, this rhythm changes. The legs stay bent at the hips and knees, and the muscles that normally assist circulation remain relatively inactive. Without the repeated contractions of walking or standing adjustments, blood in the lower veins can move more slowly. The valves inside the veins still function, yet the assistance from muscle activity becomes less frequent. This change does not immediately disrupt circulation because the cardiovascular system is capable of adapting to many conditions. However, the pattern differs from the environment in which the system originally evolved. Another subtle effect of prolonged sitting involves the position of the hips and thighs. When the body sits, the large veins that travel through the upper legs may experience gentle compression where the thighs bend at the hips. This compression can slightly influence the path of returning blood, especially if the posture remains unchanged for a long time. In a lifestyle where posture changes frequently, these effects tend to be temporary. Movement soon restores the natural rhythm of circulation. Across the deep span of human history, the circulatory system developed alongside a body that moved regularly through its environment, walking across uneven ground, standing during tasks, and shifting posture while resting, all supported the upward movement of blood through the veins. The heart and the muscles of the legs therefore formed a cooperative system shaped by motion. Understanding this relationship helps reveal how deeply the human body is connected to patterns of movement that once defined everyday life. The relationship between movement and circulation becomes especially clear when the body returns to motion after a long period of stillness. Many people have experienced the quiet sensation that appears when they stand up after sitting for an extended time. The legs may feel heavy or slightly numb for a moment, and the first few steps often restore a feeling of normal circulation. This simple experience reveals how closely the movement of blood is connected to the movement of muscles in the lower body. When walking begins again, the calf muscles contract and release in rhythm, helping blood move upward through the veins and back toward the heart. The body gradually re-establishes the circulatory pattern that functions most naturally during motion. This pattern has deep evolutionary roots. For the vast majority of human history, daily life rarely required the body to remain seated for long durations. Instead, people alternated naturally between walking, standing, crouching, and brief periods of rest. These changes in posture repeatedly activated the muscles that assist circulation. The veins in the legs therefore experience regular cycles of compression and release. Each cycle gently advanced blood toward the heart, maintaining a steady flow through the lower body. The circulatory system evolved in partnership with this rhythm of movement. Even quiet activities once supported this process. Preparing food close to the ground, tending a fire, or shaping tools often involved positions such as squatting or kneeling. In these postures, the legs remained engaged, and the muscles surrounding the veins continued to participate in circulation. The body rarely experienced a complete pause in muscular activity. Instead, there was a constant background of small contractions that maintained both balance and blood flow. This pattern allowed the circulatory system to function smoothly throughout the day without placing excessive demand on the heart alone. Modern environments often change this pattern in subtle ways. When the body sits in a chair for long periods, the legs remain relatively still and the muscles responsible for assisting circulation become less active. The veins continue to carry blood upward, yet they rely more heavily on the pressure created by the heart and the structure of the valves within the vessels. Over time, the absence of regular muscular contractions can make the lower body feel stiff or slow to respond when movement begins again. A short walk or even a few minutes of standing can quickly restore the natural rhythm of circulation, because the muscles resume their role in assisting the flow of blood. Scientists studying the cardiovascular system have observed how sensitive circulation is to even small amounts of movement. Gentle activity such as walking at a relaxed pace or shifting weight while standing can stimulate the muscular pump of the legs. These actions encourage the veins to move blood more efficiently through the lower body. The body does not require intense exercise to activate this system. It simply responds well to regular changes in posture and movement distributed across the day. This insight reflects the conditions under which the circulatory system first developed. Across the immense timeline of human evolution, the heart and the muscles of the legs worked together within a body that moved frequently through its environment. The rhythm of steps across the ground supported the steady return of blood toward the chest. Each contraction of the calf muscles contributed to the overall balance of the circulatory system. When the body alternated between motion and rest, this partnership functioned quietly and efficiently. The human body therefore carries within it a circulatory system that expects movement to appear regularly as part of ordinary life. Through countless generations, this cooperation between muscles and blood vessels helped sustain a body that remained upright and active across the landscape. Quietly beneath the larger movements of the body exists another system of support that rarely draws attention. This system is formed by the small muscles that help the body remain upright against gravity. These muscles do not produce dramatic actions like lifting or running. Instead, they maintain balance and posture while the body stands, walks, or shifts weight from one foot to the other. Without them, the body would struggle to keep the spine aligned above the pelvis and the head balanced over the shoulders. In everyday life, these muscles operate so smoothly that most people are barely aware of their activity. Yet they play an essential role in the structure of the human body. When a person stands upright, gravity pulls downward through the skeleton. The spine, pelvis, and legs must coordinate to keep the body from collapsing forward or backward. Small muscles along the back respond continuously to this challenge. They make tiny adjustments to stabilize the vertebrae and maintain the natural curves of the spine. At the same time, muscles in the abdomen engage gently to support the front of the torso. These muscles form a balanced system that holds the body steady while allowing freedom of movement. The process happens automatically through signals from the nervous system that respond to changes in balance. Even a slight shift in posture can activate these muscles without conscious effort. Walking adds another layer to this quiet activity. As the legs move forward and the body's weight shifts from one side to the other, the muscles around the spine and pelvis adjust to keep the torso stable. Each step introduces small changes in balance that must be corrected instantly. The body responds by engaging the stabilizing muscles in subtle cycles of contraction and relaxation. This coordination allows the head and upper body to remain relatively steady while the legs perform the work of movement. Without these adjustments, the body would sway dramatically with each step. The stabilizing muscles therefore act like a continuous support system that protects the spine while the body moves through space. The hips also play a crucial role in maintaining upright posture. Large muscles surrounding the pelvis guide the alignment of the lower body and help stabilize the trunk during standing and walking. When a person stands on one leg during a step, the hip muscles on that side contract to prevent the pelvis from dropping. This action may appear minor, yet it occurs repeatedly during every step taken throughout the day. Over many years, these muscles develop the endurance required to maintain posture for extended periods of activity. Their strength does not come from brief intense effort, but from steady use during everyday movement. Anthropologists studying the posture of people living in more traditional environments have often noted how naturally balanced their stance appears. When standing or working close to the ground, their bodies remain upright with minimal visible tension. The stabilizing muscles of the trunk and hips perform their role quietly, allowing the skeleton to remain aligned without external support. Because movement and posture adjustments occur frequently throughout the day, these muscles remain engaged and responsive. The body therefore maintains balance through an ongoing partnership between muscles and gravity. Over the long span of human evolution, this system developed in bodies that spent much of the day upright. Standing, walking, bending, and carrying objects all required the stabilizing muscles to function continuously. The body gradually adapted to this demand by strengthening the structures that maintain posture. These muscles became part of the body's automatic background activity, supporting the skeleton without conscious effort. Their presence reminds us that the human body evolved within an environment where balance and movement were constant companions to everyday life. Maintaining an upright posture may appear effortless, yet it requires a continuous dialogue between the nervous system and the muscles that surround the spine and pelvis. The body does not simply stand like a rigid structure. Instead, it behaves more like a flexible tower that constantly corrects its position against gravity. Tiny shifts occur almost every moment. The ankles adjust slightly when the body sways forward or backward. The hips respond by stabilizing the pelvis. Muscles along the spine engage gently to maintain the natural curves that support the torso. These corrections are subtle and often invisible, but they form the foundation of human balance while standing. Scientists sometimes refer to this system as postural control. At its core lies a network of sensory signals that inform the brain about the body's position in space. Sensors within the muscles and joints detect changes in tension and angle. The inner ear contributes information about balance and orientation. Even the eyes play a role by helping the brain understand the body's relationship to the surrounding environment. When these signals reach the nervous system, the brain responds by sending instructions back to the muscles that maintain posture. The process occurs rapidly and continuously, allowing the body to remain stable while adapting to small disturbances. In a lifestyle that includes frequent movement, this system remains active throughout the day. Walking across uneven ground requires constant adjustments in posture. The stabilizing muscles of the trunk respond instantly as the body encounters small variations in terrain. Even while standing still, the body rarely remains perfectly motionless. Gentle swaying occurs as the muscles maintain equilibrium. These movements are small enough that they usually pass unnoticed, yet they keep the stabilizing muscles engaged and responsive. Through this repeated activity, the body maintains the coordination required to remain upright with minimal effort. The hips serve as a central point in this system of balance. Positioned between the legs and the spine, the pelvis helps transmit forces between the upper and lower body. Muscles surrounding the hips coordinate with those along the spine to maintain alignment during standing and walking. When the body shifts weight to one leg, these muscles activate to keep the pelvis level and prevent excessive tilting. This stabilization protects the spine from unnecessary strain while allowing the legs to move freely. Over many years of regular activity, the endurance of these muscles develops naturally through repeated use. When the body spends long periods seated, the demands placed on this system of postural control become very different. A chair provides external support for the torso and pelvis, reducing the need for stabilizing muscles to remain active. The nervous system no longer receives the same pattern of signals related to balance and weight distribution through the legs. The muscles responsible for maintaining posture can therefore become less engaged during long stretches of sitting. When the body eventually returns to standing, these muscles must resume their role in maintaining balance. The transition may feel unfamiliar at first, not because the muscles have lost their ability to function, but because they have been inactive for a time. Anthropological observations of communities where people spend much of their day standing, walking, or working close to the ground reveal a striking contrast. Individuals in these environments often maintain upright posture with little visible effort. Their stabilizing muscles remain accustomed to frequent engagement because their daily activities continually activate the system of postural control. Standing and moving remain integrated into the natural rhythm of life rather than appearing as separate activities. Over the long course of human evolution, the ability to maintain balance while upright became a defining feature of the human body. The stabilizing muscles of the spine and hips evolved within an environment where gravity constantly interacted with a moving body. These muscles formed a quiet foundation that allowed the skeleton to remain aligned while the body explored the landscape. Understanding this system reveals how deeply posture and movement are connected within the structure of the human body. Beneath the visible posture of the human body lies a continuous conversation between muscles, joints, and the nervous system that allows balance to be maintained without conscious effort. Standing upright may appear simple, yet the body is never perfectly still while doing so. Tiny movements occur constantly as the body responds to gravity and adjusts its alignment. The ankles shift slightly, the hips correct small changes in weight, and the muscles along the spine engage to keep the torso balanced above the pelvis. These adjustments are subtle, but they repeat continuously throughout the day whenever a person remains upright. This quiet activity forms the foundation of what scientists describe as postural stability. It is a system that developed in a body that expected to remain upright and moving for long periods rather than supported by external structures. At the center of this system lies the nervous system, which continuously gathers information about the body's position. Specialized sensors inside muscles and joints detect tension and movement. These sensors send signals through nerves to the brain, informing it about the angle of joints and the distribution of body weight. The inner ear also contributes to this process by providing information about balance and orientation in space. Even vision plays a role by helping the brain understand how the body relates to the surrounding environment. When these streams of information reach the brain, the nervous system sends signals back to specific muscles that adjust posture accordingly. The process occurs extremely quickly, often within fractions of a second. Because of this rapid feedback loop, the body can maintain balance without requiring conscious thought. Walking through the landscape further strengthens this system of postural control. Uneven terrain introduces small disturbances in balance that the body must correct immediately. A stone beneath the foot, a slight slope in the ground, or a change in direction requires the muscles of the hips and trunk to respond instantly. The stabilizing muscles surrounding the spine contract to maintain alignment, while the hips adjust the position of the pelvis over the legs. These corrections occur repeatedly with each step. Over time, this constant engagement trains the muscles and nervous system to cooperate efficiently. The body becomes skilled at maintaining balance while moving through space. This process does not depend on intense effort. Instead, it relies on frequent, low-level activity distributed across many hours of the day. When the body alternates between standing, walking, bending, and resting close to the ground, the system of postural control remains active and responsive. The muscles responsible for stability receive regular signals from the nervous system, allowing them to maintain strength and coordination. Even small shifts of weight during quiet standing contribute to this ongoing training process. In a lifestyle shaped by regular movement, balance becomes an automatic part of daily life rather than a skill that requires deliberate attention. Sitting changes the way this system operates because external support replaces part of the body's natural stabilizing work. When a person sits in a chair, the pelvis rests against a surface that supports the torso. The muscles responsible for maintaining upright posture receive fewer signals from the nervous system because the body no longer needs to correct small shifts in balance. The feedback loop between the muscles, joints, and brain becomes quieter during long periods of sitting. When the body eventually returns to standing, the stabilizing muscles must resume their role in maintaining posture and balance. The system remains capable of doing this, but it may take a short time for the muscles to respond as actively as they did during regular movement. Across the immense span of human evolution, the system of postural control developed within a body that spent much of its time upright and in motion. The stabilizing muscles of the trunk and hips formed a partnership with the nervous system that allowed humans to maintain balance while moving through complex environments. This partnership reflects a body shaped by gravity and terrain, a body designed to remain active rather than supported by prolonged stillness. Long before chairs and elevated furniture appeared in human life, the body learned to rest in ways that remained closely connected to the ground. These postures were not simply moments of relaxation. They formed part of a continuous rhythm between movement and rest that shaped how the joints, muscles, and spine functioned throughout the day. When early humans paused during their activities, they often lowered themselves into positions such as squatting, kneeling, or sitting directly on the earth. Each of these postures allowed the body to rest while still maintaining a degree of muscular engagement and balance. The body remained ready to move again at any moment. One of the most common of these ancient postures is the squat. In a full squat, the hips lower toward the heels while the feet remain flat on the ground. The knees bend deeply, and the spine stays relatively upright as the body balances above the feet. This position distributes weight across the legs and feet while allowing the muscles of the hips and ankles to remain active. Because the body must maintain balance, small adjustments occur continuously in the joints and muscles. These adjustments keep circulation active and prevent the body from settling into a completely passive state. Anthropologists observing many traditional societies have noted how easily people move into and out of this posture during everyday tasks. Squatting can be used while preparing food, tending a fire, or resting during a pause in movement. The posture allows the body to remain close to the ground without requiring an external support structure. Kneeling represents another posture that once appeared frequently in daily life. In this position, the body rests partially on the knees while the torso remains upright. The hips remain flexed, yet the spine can maintain its natural curves as the body balances above the pelvis. Kneeling positions often allow the body to shift gently between different angles, especially when the ground beneath the knees is uneven. These small shifts activate muscles in the hips, thighs, and lower back, maintaining a light level of muscular engagement even during rest. As with squatting, kneeling can be easily interrupted when the body needs to stand or walk again. Sitting directly on the ground also formed part of this range of postures. Unlike sitting in a modern chair, ground sitting often involves varied leg positions. The legs may cross in front of the body, extend outward, or fold beneath the torso. Because the ground rarely provides perfectly uniform support, the body naturally adjusts its posture over time. The pelvis shifts slightly to maintain balance, and the spine changes angle as the body seeks a comfortable position. These small adjustments prevent the joints from remaining locked in a single configuration. Even during quiet moments, the body continues to engage in subtle movements that distribute pressure across different parts of the skeleton. The variety of these ground-based postures allowed the body to alternate between movement and rest without losing its connection to balance and gravity. The hips, knees, and ankles remained capable of moving through a wide range of angles. Muscles responsible for maintaining posture remained lightly active rather than completely disengaged. Circulation continued to benefit from these gentle adjustments as the body shifted weight and changed position. In this way, resting did not represent a complete interruption of movement, but rather a softer phase within the overall rhythm of daily activity. Across the long span of human history, these postures formed an important part of how the body interacted with the environment. The absence of chairs and elevated seating encouraged people to remain flexible in the way they rested. The body did not rely on a single fixed position for comfort. Instead, it moved naturally between standing, walking, squatting, kneeling, and sitting on the ground. Each posture played a role in maintaining the balance between activity and rest that once characterized ordinary life. Ground-based postures did more than simply provide a place for the body to pause. They created a subtle rhythm of movement even during rest. When a person sits on the ground, squats, or kneels, the body rarely remains fixed in exactly the same position for long. The hips may rotate slightly to relieve pressure. The knees shift a few degrees to adjust balance. The spine changes its angle as the torso settles or rises gently with breathing. These small adjustments occur naturally because the ground does not hold the body in one rigid shape. Instead, it encourages constant micro-movements that distribute pressure across the joints and muscles. Over time, these quiet adjustments allow the body to remain flexible while resting. Anthropologists who study daily movement patterns in traditional societies often observe this phenomenon clearly. People who spend much of their lives sitting or working close to the ground tend to shift positions frequently without thinking about it. A person sitting near a fire may begin with legs crossed, later extend one leg, then shift to a squat before standing again. Each transition happens smoothly and without deliberate planning. These changes in posture allow the hips, knees, and ankles to move through different angles during the day. As a result, the joints remain accustomed to a wide range of motion. The body continues to experience movement even during quiet moments. Another important aspect of ground-based resting is how it influences the hips. The human hip joint is capable of rotating in many directions. Squatting, kneeling, and cross-legged sitting each require different degrees of hip flexion and rotation. These varied positions encourage the surrounding muscles and ligaments to remain flexible. When the body transitions between these postures regularly, the hips experience gentle stretching and strengthening at the same time. Over the course of years, this natural variability helps maintain mobility in the lower body. The knees also benefit from these varied postures. When a person kneels or squats, the knee joint bends deeply and then straightens again when the body stands. This repeated movement allows the tissues inside the joint to experience cycles of compression and release. These cycles help maintain the smooth function of the cartilage that lines the joint surfaces. The knee, therefore, remains accustomed to moving through a large range of motion rather than staying fixed at one angle. In environments where these postures appear regularly throughout daily life, the knees continue to adapt to this pattern of movement. Even the ankles participate in this quiet rhythm. Squatting requires the ankles to flex deeply as the knees move forward above the feet. When standing again, the ankles extend and help lift the body upward. These movements maintain flexibility in the lower leg and keep the joints responsive to changes in posture. Over time, this flexibility allows the body to move easily between different positions on the ground. The ankles remain capable of supporting balance across uneven terrain, as well as during varied resting positions. The ground itself, therefore, acts as a kind of natural guide for posture. Because it lacks the uniform structure of furniture, it encourages the body to remain adaptable. People resting on the ground naturally reposition themselves as the body seeks comfort. These shifts may appear minor, yet they create a constant background of movement that keeps joints, muscles, and connective tissues active. The body never fully disconnects from gravity and balance. Instead, rest becomes part of the broader cycle of motion that defines daily life. Over the immense span of human history, these postures formed a bridge between activity and rest. The body moved across the landscape through walking and standing, then paused briefly in positions that maintained flexibility and balance. Squatting, kneeling, and sitting on the ground allowed the body to recover while still remaining ready to move again. This natural variability in posture helped preserve the mobility of the joints and the responsiveness of the muscles. In a world without chairs, the body never became locked into a single resting position for very long. Across long stretches of human history, resting close to the ground allowed the body to remain connected to the forces that shape posture and movement. Gravity continued to interact with the joints even during quiet moments. The hips supported part of the body's weight while the feet or knees maintained contact with the ground. The spine adjusted its curves as the torso balanced above the pelvis. Because these positions required the body to maintain its own balance, the muscles that stabilize posture remained lightly engaged. The body never became completely passive. Even during rest, there was a quiet background of muscular activity that helped maintain strength and coordination. This connection to gravity also influenced how people rose from rest and returned to movement. When a person squats or sits on the ground, standing again requires the coordinated effort of the hips, knees, and ankles. The body leans slightly forward, the legs extend, and the spine aligns over the pelvis as the person rises to an upright position. This motion activates many of the same muscles used during walking. Over the course of a day, these repeated transitions between ground postures and standing reinforce the natural coordination of the lower body. The joints move through a wide range of angles, and the muscles remain accustomed to supporting the body's weight. In this way, resting on the ground blends smoothly into movement rather than separating the two activities. Anthropologists studying traditional communities often note how fluidly people move between these positions. Someone may lower into a squat to prepare food, shift into a kneeling posture while working with tools, and later sit with legs extended while resting briefly. Each posture flows into the next without the need for external support. The ground allows the body to choose many possible configurations, rather than fixing it in a single arrangement. This flexibility creates a natural variety in how the joints are used throughout the day. Because the body experiences many different positions, no single joint angle dominates for long periods. The hips rotate, the knees bend and straighten, and the ankles flex repeatedly as people change posture. This variability helps distribute pressure across different tissues in the joints. Cartilage surfaces experience changing patterns of compression and release rather than remaining under constant pressure in the same direction. Muscles surrounding the joints remain active enough to maintain their strength, while connective tissues retain their elasticity through gentle stretching. Over time, the body adapts to this pattern of varied movement by maintaining a broad range of mobility. Another subtle effect of ground-based resting is the way it preserves the body's awareness of balance. When sitting in a chair, the body often relies on the backrest and seat to maintain stability. On the ground, however, the body must maintain its own equilibrium. Even small changes in position require adjustments in the muscles of the trunk and hips. These adjustments keep the nervous system engaged with the body's orientation in space. The sense of balance therefore remains active even during quiet periods of rest. Across the immense timeline of human evolution, this relationship between rest and movement shaped the body's expectations. Rest did not mean complete stillness. It meant shifting into a different posture that still maintained contact with gravity and balance. Squatting, kneeling, and sitting on the ground allowed the body to recover, while preserving the natural rhythm of subtle motion. The joints remained flexible, the muscles remained responsive, and the body remained ready to stand and move again. Seen through this historical perspective, these ground-based postures form an important chapter in the story of how the human body developed within a moving world. For most of human history, the rhythm of daily life continued to revolve around movement. Walking, gathering, carrying, and working close to the ground shaped how the body interacted with the environment. Yet at a certain point in the story of human civilization, the relationship between the body and movement began to change. This change did not happen suddenly. It appeared gradually as human communities began to settle in one place for longer periods of time. The transition from a fully mobile lifestyle to a more stable form of living introduced new patterns of work, new structures of space, and eventually new postures that had rarely dominated earlier human life. One of the most significant moments in this shift came with the development of agriculture. When humans began cultivating crops, they started to remain near the same land for extended seasons or even generations. Fields required regular attention throughout the year. Seeds were planted, plants were tended, and harvests were gathered at specific times. Because crops grew in fixed locations, communities could no longer move freely across the landscape in the same way that hunter-gatherer groups had done for thousands of years. Villages began to form near fertile soil and reliable water sources. Houses were built with more permanent materials, and daily activities gradually concentrated within smaller geographic areas. Even within these early agricultural communities, movement still played an important role. Farming required bending, lifting, carrying, and walking between fields and storage areas. However, the structure of daily work began to include longer periods spent in one location. Tasks such as grinding grain, weaving fibers, shaping pottery, or repairing tools often occurred within sheltered spaces near the home. These activities could be performed while seated or kneeling for longer intervals than was typical in earlier mobile lifestyles. Although the body still moved frequently during agricultural labor, the appearance of more stationary work introduced a subtle change in posture patterns throughout the day. Archaeological evidence from early farming settlements reflects this transformation in daily life. Remains of grinding stones, storage containers, and hearths often appear within the same household spaces, suggesting that food preparation and craft work took place repeatedly in the same areas. Over time, these tasks may have encouraged people to remain in similar postures for longer periods while working with their hands. The ground still served as the primary surface for sitting or kneeling, but the duration of these positions gradually increased as communities organized work around fixed locations. Another important shift occurred as villages grew larger and social structures became more complex. With the development of trade, governance, and craft specialization, certain roles required individuals to spend extended time performing detailed manual work. Potters, weavers, scribes, and toolmakers often concentrated their attention on tasks that required steady hands and focused posture. These activities sometimes encouraged the body to remain seated or kneeling for longer stretches than earlier forms of subsistence work. Even so, the ground and simple surfaces remained the primary support for the body rather than raised seating structures. The introduction of these more stationary tasks did not immediately replace the movement patterns that had defined human life for so long. Instead, it added a new layer to the daily rhythm of activity. People continued to walk through fields, gather materials, carry goods, and perform physical labor outdoors. Yet within homes and workshops, the body sometimes remained in more fixed positions while performing repetitive tasks. Over generations, this gradual shift began to reshape the balance between movement and stillness within human societies. When viewed across the immense timeline of human evolution, the agricultural transition represents one of the first moments when the human body encountered extended periods of stationary work as part of ordinary life. Movement remained essential, but the pattern of activity began to change. The body that had evolved within a landscape of constant mobility slowly adapted to environments where work and living spaces became more permanent. This shift marked the beginning of a new chapter in the relationship between the human body and the postures it would experience each day. As early agricultural societies grew, the organization of daily life slowly became more structured around particular places and repeated tasks. Fields, homes, and workshops created stable centers of activity that did not shift with the seasons in the same way that earlier camps had done. This stability changed how the body interacted with work throughout the day. Instead of traveling long distances while searching for food, many people began performing certain activities in the same locations again and again. The body still moved frequently through fields and paths between homes, yet periods of concentrated work began to appear more often. These moments of focused activity sometimes required individuals to remain in similar postures while working with their hands. Grain processing offers a clear example of this change. In many early farming societies, harvested grain had to be ground into flour using heavy stones. Archaeological discoveries of grinding stones, known as querns, show that this activity was performed repeatedly in domestic spaces. The process required a person to kneel, squat, or sit close to the ground while moving a smaller stone back and forth across the grain. This work could continue for extended periods as families prepared food for daily meals. Although the body still shifted occasionally, the repetitive nature of the task encouraged longer intervals in similar positions than those seen in more mobile hunting and gathering lifestyles. Weaving and textile production created another form of concentrated work. Early weaving techniques required individuals to sit or kneel near simple looms while guiding threads into place. This activity demanded patience and careful hand movements. Because the work focused on fine motor control, the body often remained relatively steady while the hands performed detailed actions. Archaeological evidence from ancient settlements frequently includes loom weights and spindle whirls, indicating that textile production played a regular role in domestic life. These tools reveal how certain crafts introduced new patterns of posture that differed from the constant movement associated with foraging across the landscape. Pottery making also illustrates the emergence of more stationary tasks. Shaping clay vessels required steady hands and careful attention as the clay was formed into useful containers. Early potters often worked close to the ground, sitting or kneeling while shaping the clay. The body remained near the same position while the hands rotated and molded the material. Once again, the ground served as the primary surface supporting the body. Even though the posture differed from standing or walking, it still allowed the body to maintain contact with gravity and balance in ways that remained closer to earlier human postures than modern seated furniture would later allow. Despite these emerging forms of stationary work, daily life in early agricultural societies still included significant movement. People walked between homes, fields, water sources, and storage areas throughout the day. Harvesting crops required bending, lifting, and carrying heavy loads. Animals needed to be tended and materials transported across villages. These activities ensured that the body continued to experience many of the movements that had shaped human anatomy across earlier periods of evolution. The new patterns of seated or kneeling work, therefore, appeared alongside continued physical activity rather than replacing it entirely. Over time, however, the balance between movement and stillness gradually began to shift. As villages grew larger and craft production increased, some individuals spent more of their time performing specialized tasks that involved detailed manual work. These roles encouraged longer stretches of focused posture while crafting tools, textiles, or pottery. Even so, the body still relied on ground-based positions rather than elevated seating. The environment had not yet introduced structures that would hold the body in a fixed seated posture for many hours at a time. The ground remained the most common surface for both work and rest. This stage in human history therefore represents a transitional period. The body continued to move through the landscape as it had for thousands of years, yet new forms of work slowly introduced moments of stillness that had previously been rare. Agriculture created the first conditions in which certain daily tasks encouraged people to remain in similar positions for longer intervals. These subtle changes in posture patterns marked an early step toward the more stationary environments that would later appear in human societies. As agricultural communities continued to grow, the structure of human settlements gradually changed the way people organized their time and movement. Villages that once consisted of only a few dwellings slowly expanded into more complex environments where homes, storage areas, and workspaces formed stable centers of daily activity. Paths between these places became familiar routes walked many times each day. Over generations, people began to spend more of their lives within these settled environments rather than traveling across wide landscapes. Movement still existed, yet it often occurred within smaller boundaries. The body continued to walk, carry, and work, but the scale of movement slowly narrowed as communities developed permanent homes and shared spaces. Within these settlements, the organization of domestic life created new rhythms of posture. Tasks such as preparing food, repairing tools, weaving fibers, or shaping clay frequently took place near the ground inside homes or sheltered work areas. These tasks often required concentration and repeated hand movements, encouraging the body to remain in similar positions while the work was completed. The ground still served as the main surface for sitting, kneeling, or squatting, and people continued to change posture occasionally. However, the repeated nature of these activities sometimes led individuals to remain in these positions for longer stretches than earlier hunter-gatherer lifestyles had required. The body gradually experienced more moments in which stillness accompanied careful manual work. Archaeological excavations of ancient houses provide subtle evidence of these patterns. In many early settlements, tools used for food preparation and craft production appear clustered within domestic spaces rather than scattered across open landscapes. Grinding stones, pottery fragments, weaving tools, and hearth remains often appear together inside or near homes. This distribution suggests that many daily tasks were performed repeatedly in the same areas. When people returned to these spaces day after day, the body naturally adapted to the posture patterns associated with those tasks. Sitting or kneeling near the ground while working became part of the routine of domestic life. Yet even as these new patterns appeared, the broader rhythm of human movement remained present. Agricultural work required people to walk through fields, gather harvests, carry water, and transport materials between homes and storage areas. Animals needed to be tended and fences repaired. Firewood had to be collected and food prepared outdoors. These responsibilities ensured that movement continued to play a central role in everyday life. The body therefore alternated between periods of activity across the landscape and quieter intervals of work within domestic spaces. The balance between motion and stillness was beginning to shift, but it had not yet disappeared. One important detail distinguishes this stage of human history from later developments. Even when people remained seated while working, the positions they used were still closely connected to the ground. The hips, knees, and ankles maintained a wide range of movement as individuals shifted between squatting, kneeling, or cross-legged sitting. These postures allowed the body to remain flexible and responsive rather than fixed in a rigid seated arrangement. The absence of elevated furniture meant that people could rise and return to standing easily when work was finished. The body still moved fluidly between resting and standing positions. Over many generations, however, the gradual increase in domestic tasks and specialized crafts introduced more opportunities for extended stationary work. Communities were becoming more organized, and certain individuals began focusing on particular skills such as pottery, weaving, or tool production. These forms of work required patience and precision, encouraging longer periods of concentrated posture. The seeds of a more stationary lifestyle were quietly appearing within these early settlements. Seen across the immense span of human history, this moment represents an important turning point. The human body that evolved within a world of constant mobility was beginning to encounter environments where work sometimes encouraged stillness. Movement remained essential, yet the conditions of daily life were slowly changing. The balance between activity and rest was shifting in subtle ways that would continue to develop in the centuries that followed. As human societies continued to grow more organized, another quiet change began to appear in the environments where people lived and worked. Over long periods of time, the objects that surrounded daily life gradually became more specialized. Tools, containers, and work surfaces slowly evolved to serve particular tasks more efficiently. Among these changes, one small invention would eventually alter how the human body rested and worked: the raised seat. For most of human history, the ground had been the primary surface for resting and working. Squatting, kneeling, or sitting directly on the earth allowed the body to remain flexible and balanced while staying connected to gravity. The hips and knees could move freely, and the body could easily transition between rest and movement. Raised seating structures, however, introduced a different relationship between the body and the environment. Instead of lowering the body close to the ground, these structures lifted the pelvis above the floor and supported the body's weight from below. The earliest forms of raised seating appear in the archaeological record thousands of years after the first agricultural settlements. In ancient civilizations, such as those of Mesopotamia and Egypt, carved stools and simple chairs began to appear in artistic depictions and preserved artifacts. These early seats were often constructed from wood, stone, or woven materials. Their design was relatively simple, typically consisting of a flat surface supported by legs. Unlike modern furniture, they did not always include backrests or cushioning. Even so, they introduced a new way for the human body to rest while remaining above the ground. It is important to understand that these early seats were not used by everyone. In many ancient societies, raised seating was often associated with status or authority. Leaders, officials, or elders sometimes occupied seats while others continued to sit or kneel on the ground. Artistic images from ancient cultures frequently show rulers seated on raised platforms while attendants stand nearby. These scenes reveal that the act of sitting above the ground carried symbolic meaning. The seat elevated certain individuals physically as well as socially. Over time, however, the practical advantages of raised seating became more widely recognized. A stool allowed a person to rest without bending the knees deeply or lowering the body fully to the ground. For individuals performing certain types of work, this position could provide stability while allowing the hands to operate at a convenient height. Crafts such as writing, carving, or detailed toolmaking sometimes benefited from a posture where the body remained upright and supported. As these activities became more common in complex societies, raised seating gradually appeared in more environments. The introduction of seats also changed how the body aligned during rest. When sitting on the ground, the hips and knees bend deeply, and the body must balance itself above the feet or legs. When sitting on a raised surface, the legs hang downward or extend forward while the pelvis rests on the seat. The muscles responsible for maintaining balance become less active because the structure of the seat supports the body's weight. Over time, this posture encourages the body to remain relatively still while seated. Movement becomes less necessary for maintaining stability. Across centuries, these changes slowly influenced the environments where people spent their time. As buildings became more permanent and interior spaces more structured, furniture began to appear alongside other household objects. Seats, benches, and eventually chairs became part of the architecture of daily life. The body that had evolved within a world of ground-based rest was beginning to interact with objects designed to hold it in place above the floor. Seen through the long lens of human evolution, this shift represents a significant turning point. The raised seat introduced a posture that separated the body from the ground and reduced the need for constant balance and adjustment. Although it began as a symbol of authority and specialized work, it gradually became a more common feature of human environments. With it came the possibility of longer periods spent sitting in a single position, a posture that the human body had rarely experienced throughout most of its history. As raised seating gradually appeared in human environments, the design of these objects began to evolve alongside the needs of growing societies. Early stools and simple seats were originally practical tools, often constructed with minimal materials and straightforward shapes. Yet over centuries, these objects slowly became more refined. Artisans began shaping wood, carving decorative patterns, and experimenting with different forms of support for the body. What had once been a simple platform for sitting gradually developed into a more structured piece of furniture designed to hold the body in a particular posture. One of the most important additions to the design of seating was the backrest. A flat stool allows the body to rest above the ground, but it still requires the muscles of the back and abdomen to remain active in order to keep the torso upright. The introduction of a backrest changes this relationship. When the back leans against a vertical surface, the structure of the chair begins to carry part of the weight that would otherwise be supported by the muscles of the trunk. The spine no longer needs to maintain the same level of active stabilization because the chair provides external support. This change allows the body to remain seated with less muscular effort for longer periods of time. Historical evidence suggests that chairs with backrests were often associated with positions of authority or specialized roles within early civilizations. In ancient Egypt, for example, carved chairs with supportive backs appear in tomb paintings and surviving artifacts linked to high-ranking individuals. These chairs sometimes included carefully shaped surfaces that followed the curve of the back or provided arm supports. Such designs were not simply decorative. They allowed the person seated to remain comfortable and stable for extended periods, particularly during activities such as writing, administration, or ceremonial gatherings. As societies continued to develop more complex systems of governance and record-keeping, seated work became increasingly common in certain professions. Scribes, administrators, and scholars often spent long hours working with written materials. In these contexts, The chair served as a tool that allowed the body to remain in a steady position while the hands performed careful tasks. The combination of a raised seat and a backrest created an environment where the torso could remain relatively still while attention focused on intellectual or manual work. Over time, this arrangement gradually influenced how indoor spaces were organized. Tables and desks began to appear alongside chairs, creating surfaces where writing, reading, and detailed craftsmanship could occur. The relationship between the human body and the built environment slowly transformed. Instead of adapting posture to the ground and surrounding terrain, the body began adapting to objects specifically designed to support it. Furniture became part of the architecture of daily life, shaping how people position themselves while working or resting indoors. This transformation also changed the dynamics of movement within interior spaces. When sitting on the ground, people tend to shift posture regularly because the body must maintain balance. On a chair with a backrest, the body can remain stable with far fewer adjustments. The pelvis rests firmly on the seat, the feet rest on the floor, and the spine leans against the back support. Because the chair provides stability, the small balancing movements that normally occur during ground sitting become less frequent. The body can remain in a similar configuration for extended periods without needing to reposition itself. Across generations, these subtle changes in posture gradually became part of everyday experience in many settled societies. Chairs and benches appeared in homes, public buildings, and places of administration. Although many forms of physical labor still required standing and movement, the presence of furniture introduced new opportunities for prolonged sitting within human environments. The body that had evolved within a landscape of constant posture variation was slowly encountering spaces designed to hold it in one position for longer intervals. As chairs and structured seating became more common within homes, workplaces, they gradually changed the relationship between the human body and the spaces it occupied. Furniture did not simply offer comfort, it also shaped how people positioned themselves during long periods of activity. Once tables, desks, and chairs began to appear together within indoor environments, the body often settled into arrangements where the torso faced forward, the arms rested near a working surface, and the legs remained bent beneath the body for extended periods. These arrangements created a stable framework for many kinds of tasks, particularly those involving writing, reading, calculation, or detailed craftsmanship. In earlier periods of human life, posture had been guided primarily by the shape of the ground and the needs of movement. When resting on the earth, the body naturally shifted from one position to another because the surface did not enforce a single arrangement. The hips rotated, the knees changed angle, and the spine adjusted frequently to maintain comfort and balance. Furniture altered this dynamic by creating surfaces that encouraged the body to remain in a consistent orientation relative to the objects placed upon them. A chair positioned in front of a table gently guided the body into the same posture each time the person returned to work. Over generations, this repeated alignment between the body and its environment gradually became part of everyday life in many societies. As indoor work increased, the number of hours spent sitting during certain activities slowly expanded. Scholars, clerks, teachers, and artisans often performed tasks that required careful concentration while seated at work surfaces. The stability provided by furniture allowed attention to remain focused on intellectual or manual tasks without the need to continually adjust posture for balance. In this sense, chairs and desks became tools that supported new forms of human activity. They allowed individuals to organize information, create written records, and perform detailed work that contributed to the growth of complex societies. Yet this stability also meant that the body sometimes remained in the same configuration for longer stretches of time. The hips stayed flexed while the knees bent beneath the body. The spine leaned forward or rested against the back of a chair. The muscles responsible for maintaining balance became less active because the surrounding structures provided support. Movement was no longer required to maintain equilibrium in the same way it had been when sitting or resting on the ground. The body could remain relatively still while the mind and hands performed their tasks. The spread of furniture also influenced how interior spaces were organized within buildings. Rooms were increasingly designed around stationary activities. Tables were placed near sources of light for reading or writing. Chairs surrounded communal areas where people gathered for discussion or work. Storage areas held tools and materials within reach of seated individuals. These arrangements encourage people to return repeatedly to the same locations for particular activities, reinforcing the habit of sitting while performing certain forms of labor. Even as these environments developed, many aspects of human life still required movement. Farming, construction, travel, and manual labor continued to involve standing, walking, lifting, and carrying. The body therefore experienced a mixture of active and stationary moments throughout the day. However, the presence of chairs introduced a new possibility that had rarely existed before: the ability to remain seated comfortably for extended intervals without needing to change posture frequently. Over centuries, this possibility slowly reshaped daily routines in subtle ways. Seen across the immense timeline of human history, the widespread adoption of chairs represents a quiet but meaningful transformation. The human body that evolved within environments of varied posture and continuous motion was beginning to inhabit spaces designed for prolonged stillness. Furniture created conditions where the body could rest in a single configuration while attention focused on intellectual and social tasks. This shift did not eliminate movement from human life, but it introduced a new balance between motion and stillness that would continue to evolve in the centuries ahead. As human societies entered the age of industry, the relationship between the body and daily movement changed in ways that had rarely occurred before. For thousands of years, most forms of work required people to move through landscapes, fields, and workshops while using the strength of their bodies to accomplish tasks. Walking, lifting, bending, and carrying remained common elements of everyday life, even in settled agricultural communities. Yet the emergence of large-scale industry introduced new environments where the structure of work increasingly centered around machines and fixed workstations. These environments gradually encourage people to remain in one place for longer periods while performing specialized tasks. Factories and workshops organized labor around equipment that operated continuously. Workers often stood or sat near the same machine for much of the day, repeating specific actions as materials passed through the production process. Although some forms of industrial labor required physical effort, the movement patterns within these spaces differed from the varied and distributed movement that had characterized earlier human work. Instead of walking through fields or gathering materials across wide areas, workers frequently remained near the same position as the rhythm of machines guided the pace of activity. This arrangement concentrated work within confined spaces and structured time into long blocks of repetitive tasks. The development of offices during the same historical period introduced another significant shift in posture patterns. As governments, businesses, and institutions expanded, written records and administrative work became increasingly important. Clerks, accountants, and administrators spent many hours reading documents, writing reports, and organizing information. These tasks required attention to detail and extended periods of focus. Furniture, such as desks and chairs, became essential tools that supported this type of work environment. The body often remained seated while the hands and eyes performed tasks that demanded precision rather than physical movement. Over time, office environments began to standardize the arrangement of furniture and work surfaces. Desks were positioned at consistent heights, chairs were designed to support the body during prolonged sitting, and documents or tools were placed within reach of seated workers. This design allowed individuals to remain in a stable position while completing their responsibilities. The arrangement was efficient for managing information and performing detailed tasks, yet it also encouraged the body to remain in similar postures for much of the working day. Movement became something that occurred between tasks rather than as an integral part of the work itself. Anthropologists and historians examining the transition to industrial and administrative societies often note how these environments changed the rhythm of daily life. Earlier forms of labor involved frequent shifts between different types of movement. A farmer might walk through fields, bend to plant seeds, lift harvested crops, and carry tools throughout the day. In contrast, industrial and office work often separated movement from the primary task being performed. Workers traveled to a location, remained there while completing their duties, and then left the space once the work period ended. The body therefore experienced longer intervals of stillness within environments specifically designed for efficiency and productivity. Despite these changes, the human body itself did not evolve rapidly enough to adapt to this new pattern of daily life. The bones, joints, muscles, and circulatory systems that had developed across hundreds of thousands of years remained shaped by conditions where movement occurred regularly throughout the day. The industrial era introduced environments that differed from those earlier conditions, yet the structure of the human body continued to reflect its evolutionary origins. When viewed across the immense span of human history, the rise of industrial and office work represents one of the most dramatic shifts in how the body interacts with its environment. The body that once moved across landscapes for survival was now spending increasing portions of the day within buildings designed for stationary work. Movement still existed, but its place within daily life had begun to change in ways that earlier generations would have found unfamiliar. As the industrial world gradually transformed into the modern technological age, another quiet shift appeared in the rhythm of everyday life. Machines that once required constant human supervision began to operate with greater independence, and many forms of work moved from physical production toward the management of information. Offices expanded across cities, and later computers entered homes, workplaces, and schools. These developments changed not only how people worked, but also how long the body remained seated while interacting with tools designed for the mind rather than the muscles. The arrival of computers marked a particularly important moment in this transformation. Early office work had already encouraged sitting while writing or reading documents, yet the introduction of digital systems expanded the range of tasks that could be completed from a single seated position. A person could now communicate, calculate, design, and organize complex systems of information without leaving the desk. The hands moved across a keyboard or mouse while the eyes focused on a screen positioned in front of the body. Because the tools of work were concentrated in one place, the body often remained in the same posture for extended periods, while attention remained fixed on the flow of information. Over time, this pattern became deeply integrated into the structure of modern workplaces. Offices arranged rows of desks equipped with computers, allowing individuals to complete their tasks within small personal spaces. Meetings occurred around tables where participants remained seated while exchanging ideas. Communication that once required walking between buildings could now happen through electronic messages delivered instantly across networks. These changes made work more efficient in many ways, yet they also reduced the amount of movement required to accomplish daily responsibilities. The body could remain seated while participating in activities that once demanded physical travel or interaction with the surrounding environment. Technology also expanded the presence of seated activity beyond the workplace. In many homes, computers, televisions, and later portable devices created new forms of entertainment and communication that took place while sitting. Reading messages, watching programs, playing games, or browsing information often occurred in chairs, on sofas, or at desks. Unlike earlier forms of leisure that involved movement through the landscape, many modern activities encourage people to remain comfortably seated for long intervals. The environment surrounding the body increasingly provided surfaces and devices that supported prolonged stillness while attention focused on screens. Researchers studying patterns of daily activity have observed how these technological environments influence the distribution of movement across the day. In earlier eras, tasks such as gathering information, delivering messages, or obtaining goods often required physical travel. Walking between locations naturally introduced movement into daily routines. Modern communication systems allow many of these tasks to occur without leaving a chair. A person may send messages, manage work responsibilities, and access large amounts of information while remaining seated in the same position for long periods. The body participates in the activity primarily through small movements of the hands and eyes rather than through larger patterns of motion. From the perspective of human evolution, this transformation is remarkably recent. The biological structure of the human body developed across hundreds of thousands of years in environments where information about the world came through movement and exploration. People walked across landscapes to gather resources, observe changes in the environment, and interact with other members of their communities. Modern technology has compressed many of these experiences into tools that deliver information directly to the seated body. The environment has become more accessible while requiring far less physical movement. This shift has created a new balance between mental activity and physical stillness in modern life. The mind may remain highly active, while the body stays relatively motionless. Although this arrangement allows humans to process enormous amounts of information, it also places the body in postures that were rarely sustained for such long durations in earlier periods of history. The contrast between these modern conditions and the evolutionary origins of the human body reveals how rapidly the environment surrounding us has changed compared with the slower pace of biological adaptation. As modern technology continued to reshape daily life, the amount of time many people spent sitting quietly increased in ways that would have been difficult to imagine in earlier periods of history. Work, communication, and entertainment gradually gathered around screens and devices that could be used from a single location. A person might begin the day seated at a desk while checking messages or organizing tasks. Hours later, the same posture might continue during meetings, document preparation, or digital communication. Even after work ended, similar positions often appeared again during leisure activities such as watching programs, reading online information, or interacting with friends through digital networks. The body remained still while attention moved rapidly across streams of information. This pattern represents a striking contrast with the environments in which the human body originally evolved. For most of the species' history, knowledge of the world came through movement. People walked across landscapes while gathering food, observing animals, searching for water, and interacting with others. Each of these activities required the body to move through space in order to obtain information about the environment. The eyes scanned the horizon while the legs carried the body forward. The hands interacted with tools and materials encountered along the way. Movement was therefore woven directly into the process of learning about the world and responding to it. Modern technology has separated many forms of information from the physical environments where they once originated. News, communication, maps, and instructions can now appear instantly on screens while the body remains seated. A person may explore distant places, speak with someone across the world, or analyze complex data without leaving the same chair. The mind travels widely through networks of information while the body experiences only minimal physical movement. This separation between mental exploration and bodily motion represents one of the most distinctive features of modern life. Researchers who examine patterns of human activity often describe this transformation as a shift towards sedentary behavior. The term refers to activities performed while sitting or lying down that involve very little physical movement. Studies in public health and anthropology have observed that many individuals in industrialized societies now spend a large portion of their waking hours in such positions. Work environments, transportation systems, and digital entertainment all contribute to this pattern. The body remains supported by chairs, vehicles, or other structures while attention focuses on tasks that require primarily cognitive effort. Despite these changes, the human body itself still reflects the long evolutionary history that shaped its structure. The skeleton, muscles, and circulatory systems developed in environments where movement occurred frequently across the day. Walking between locations, adjusting posture while resting on the ground, and performing physical tasks all created a rhythm of motion that supported the body's internal systems. The modern environment, however, often concentrates activity into smaller spaces where movement becomes optional rather than necessary. This difference between biological design and environmental conditions forms an important part of the story of modern sitting. Yet, the relationship between humans and their environment continues to evolve. Many people today have become aware of the effects of prolonged stillness and have begun exploring ways to reintroduce movement into daily routines. Standing desks, walking paths, and intentional breaks during work represent attempts to restore some of the balance that once existed naturally in earlier human environments. These adjustments suggest that the story is not simply about technology replacing movement, but about how humans continue adapting their environments to support the bodies they inhabit. Seen across the immense timeline of human history, the modern sedentary lifestyle represents a recent chapter in an ongoing relationship between the body and the world it moves through. The body remains shaped by ancient patterns of motion, even as the environments surrounding it change rapidly. Understanding this contrast allows us to see modern sitting not as a permanent condition, but as one moment within a much longer story of how humans learn to live within the spaces they create. Across the immense timeline of human evolution, the human body developed within environments where movement appeared naturally throughout the day. Walking across uneven ground, adjusting posture while resting near the earth, and performing physical tasks created a constant background of motion that shaped how the skeleton, muscles, and internal systems functioned together. The body did not experience long periods of complete stillness. Instead, activity and rest blended into a rhythm where posture changed regularly, and the body remained connected to gravity and balance. This rhythm formed the conditions under which the human body gradually adapted across hundreds of thousands of years. When viewed from this long perspective, the modern habit of sitting for many hours at a time appears as a very recent development. Raised seating, desks, offices, vehicles, and digital devices have created environments where the body can remain supported in one posture for extended intervals. These environments were designed to increase comfort and efficiency in daily life. They allow people to read, write, communicate, and perform detailed tasks without the physical demands that earlier generations faced. Yet the biological systems within the body continue to reflect the much older conditions under which they evolved. Bones, joints, muscles, and circulation still operate most smoothly when movement occurs regularly across the day. This contrast between ancient biology and modern environments does not mean that sitting itself is harmful or unnatural. Humans have always rested, paused, and spent time in quiet positions. The difference lies in the duration and repetition of those positions. In earlier environments, rest usually occurred in postures that allowed the body to shift easily and return to movement. Squatting, kneeling, or sitting close to the ground encouraged subtle adjustments in balance and posture. Modern seating structures, by contrast, often support the body so completely that the need for these small adjustments becomes less frequent. The body can remain in the same configuration for long periods without needing to reposition itself. Understanding this distinction can help explain why many people feel a sense of stiffness after remaining seated for too long. The joints and muscles of the body are accustomed to gentle cycles of motion rather than extended stillness. When the body eventually rises and begins moving again, the familiar rhythm of movement gradually returns. Walking, stretching, and shifting posture allow the internal systems of the body to resume the patterns that once appeared naturally throughout daily life. The body responds quickly to these changes because its structure remains adapted to motion. This insight does not require a return to the lifestyles of distant ancestors. Modern societies offer many benefits that earlier generations did not possess. Instead, understanding the evolutionary story of the human body invites a quieter reflection on balance. Movement does not need to be dramatic or intense to support the body's natural functions. Even small changes in posture, brief walks between tasks, or moments spent standing, can reintroduce gentle motion into environments that encourage stillness. These adjustments allow the body to experience patterns of activity that remain closer to the conditions under which it developed. When people become aware of this long history, the relationship between the body and sitting begins to appear in a different light. Chairs and modern environments are not enemies of the body. They are tools that humans created to organize work and comfort. Yet the body itself still carries the memory of a moving world, a world where balance and motion were constant companions throughout the day. Recognizing this history can inspire a quieter awareness of how often the body benefits from simple acts of movement. In the end, the question that opened this story remains gently present. The human body evolved within landscapes that required constant motion, yet modern life often invites us to remain seated for much of the day. Perhaps the deeper question is not whether sitting exists, but how humans will continue learning to balance stillness and movement within the environments they create for themselves. When we observe the structure of the human body with quiet attention, certain patterns begin to appear. The joints of the legs bend and extend through wide ranges of motion. The hips rotate in multiple directions, allowing the body to lower toward the ground and rise again with relative ease. The spine forms gentle curves that help distribute weight while the body stands upright against gravity. These features reveal a design shaped by motion rather than stillness. They suggest a body that expects to change position frequently, shifting between walking, standing, bending, and resting in different ways across the day. Over long periods of human history, these patterns emerged slowly as people moved through landscapes that required constant adjustment. The ground was rarely flat, the terrain rarely predictable. A person might step over stones, walk along slopes, crouch near water, or kneel while preparing food. Each of these activities introduced subtle variations in posture. The hips, knees, and ankles moved through many angles, while the muscles surrounding the spine worked gently to maintain balance. Rest occurred, but it usually appeared within postures that still allowed the body to remain flexible and ready to move again. Even quiet moments preserve the body's connection to gravity and equilibrium. Modern environments often organize daily life in ways that simplify these relationships. Floors are level, chairs support the body at a fixed height, and many tools are designed to operate while the body remains seated. These structures create stability and convenience, yet they also reduce the number of posture variations that the body experiences throughout the day. When the hips remain bent at similar angles for long periods, the joints move less frequently through the full ranges that once defined everyday activity. The body is still capable of these movements, but it encounters them less often during ordinary routines. Researchers who study human movement sometimes describe the body as a system that responds best to variability. Rather than depending on a single posture or repetitive pattern, the joints and muscles appear to function most comfortably when they experience many different positions over time. Walking for a few minutes, standing while speaking, bending to reach an object, or briefly changing seating posture all contribute to this variability. Each small change allows the body to distribute pressure across different tissues and maintain flexibility in the structures that support movement. This principle reflects the conditions under which the human body first developed. In earlier environments, variability appeared naturally because daily survival required interacting with a changing landscape. People rarely remained in the same posture long enough for the body to settle into complete stillness. Movement flowed quietly through the rhythm of ordinary life. Even when individuals paused to rest, the ground beneath them encouraged small adjustments that preserved a sense of balance and readiness. The body, therefore, experienced a continuous conversation between rest and motion. Modern life does not always provide these variations automatically, yet the body still responds quickly when they reappear. A short walk across a room, a moment spent standing near a window, or a gentle stretch after sitting can restore some of the natural rhythm that once occurred effortlessly in earlier environments. These movements do not need to be dramatic. They simply allow the body to remember the patterns that shaped its structure across countless generations. Understanding this history offers a quiet perspective on the relationship between humans and the spaces they inhabit. The environments people build inevitably influence how the body moves and rests. Chairs, desks, and digital devices have become familiar elements of modern life, yet the body beneath them remains deeply connected to a past where movement and posture variation were constant companions. Perhaps the most meaningful lesson from this long story is not that modern life must reject comfort or technology, but that the body continues to benefit from the gentle presence of movement within the day. When the long history of the human body is viewed as a whole, one pattern quietly appears again and again. The body was never shaped within still rooms or fixed positions. It was shaped across landscapes where motion appeared naturally as part of survival. People walked in search of water, food, and shelter. They lowered themselves to the ground while preparing meals or crafting tools. They rose again to travel, to gather, to carry, and to explore the environment around them. Movement was not a separate activity that needed to be scheduled or planned. It was simply woven into the fabric of everyday life. Across hundreds of thousands of years, the bones, muscles, and internal systems of the body slowly adapted to this rhythm. The spine learned to balance the torso above the pelvis while upright. The hips developed the ability to bend deeply and rotate in multiple directions. The knees and ankles became capable of absorbing force and guiding the body across uneven ground. Circulation evolved in partnership with the quiet contractions of the leg muscles that helped blood move upward against gravity. Even the systems responsible for balance and posture were refined within a world where the body constantly adjusted itself to shifting terrain. This evolutionary history did not produce a body designed for perfect stillness. Instead, it produced a body that remains comfortable when movement appears regularly throughout the day. Modern environments, however, often invite a different rhythm. Chairs support the body, floors remain flat, and digital devices concentrate work and communication within small spaces. These environments make many aspects of life easier and more efficient, yet they also allow the body to remain in the same posture for long intervals. A person can spend hours interacting with information, speaking with others, or completing tasks while the legs remain still and the torso remains supported by furniture. The mind may travel widely through ideas and conversations, but the body itself often moves very little. Yet even within this modern landscape, the body continues to carry the quiet memory of its origins. When a person stands after sitting for a long time, the joints begin moving again through familiar angles. The muscles of the legs engage to support the body against gravity. Blood circulates more actively as the body walks across a room or down a path. These small moments of movement often bring a subtle sense of ease, as if the body is returning to a rhythm it has known for a very long time. The response is not dramatic. It is simply the natural behavior of a body that evolved within motion. Understanding this long story offers a gentle perspective on the question that opened our exploration. The human body was not originally designed for long hours of sitting because it was shaped within environments where stillness rarely lasted very long. Movement formed the background of daily life, quietly supporting the body's structure and internal systems. Sitting itself is not a mistake or a danger. It is one of many postures that humans can use. The deeper insight lies in remembering that the body continues to benefit when stillness is balanced with motion. Across the long arc of human history, people have always created tools, spaces, and technologies that reshape their environments. Chairs, buildings, and digital devices represent part of that ongoing creativity. Yet beneath these inventions remains the same body that once walked across open landscapes under the sky. Perhaps the most meaningful question is not whether humans should sit or stand, but how the environments we build can continue. When the entire story of the human body is placed against the deep timeline of human history, the contrast between past and present becomes easier to see. For hundreds of thousands of years, human beings lived within environments where movement was not something that required planning. It simply happened as part of survival. People walked to find water, climbed small slopes to gather plants, carried materials across the landscape, and lowered themselves to the ground while preparing food or tools. Each of these actions required the body to change posture again and again. The hips bent, the knees straightened, the spine balanced above the pelvis, and the muscles of the legs supported the body against gravity. Movement appeared quietly and constantly within ordinary life. In those environments, the body rarely remained in a single position for long. Even during moments of rest, posture continued to change. Someone resting near a fire might squat for a short time, then extend their legs, then stand again when it was time to walk. The ground beneath the body encouraged flexibility because it did not hold the body in one fixed arrangement. Instead, the joints and muscles remained responsive as the body shifted between positions. Over many generations, this rhythm of posture change became part of the conditions under which the human body evolved. The skeleton, muscles, and internal systems adapted slowly within this moving world. When seen through this long evolutionary perspective, the modern environment appears very different. Within only a few centuries, human societies have built spaces that allow the body to remain still for long periods without effort. Chairs support the pelvis, backrests support the spine, and desks position tools directly in front of the seated body. Vehicles carry people across large distances while they remain seated. Digital devices allow communication, learning, and work to occur without the need to move through physical landscapes. These inventions have brought many advantages, making daily life more comfortable and efficient in countless ways. Yet they also create environments where the body can remain in the same posture far longer than it once did in earlier human history. The remarkable detail in this story is the speed at which this change has occurred. The biological structure of the human body develops slowly across evolutionary time. Small adaptations appear gradually over thousands of generations as bodies interact with the environments in which they live. In contrast, the transformation of human environments during the last few centuries has occurred extremely quickly. Cities, furniture, vehicles, and digital technologies have reshaped daily life in a very short span, compared with the deep history of human evolution. As a result, the body that once moved across open landscapes now often spends large portions of the day inside carefully designed indoor spaces. This difference does not mean that modern life stands in opposition to the human body. Humans have always shaped their surroundings through creativity and invention. Fire, clothing, tools, and shelter all changed the environments where people lived long before chairs or computers appeared. The modern world continues this tradition of shaping environments to meet human needs. At the same time, the body itself still reflects the long evolutionary past in which movement appeared naturally throughout daily life. Understanding this contrast helps reveal why even small moments of movement can feel natural and refreshing after long periods of stillness. The body responds quickly when it begins to walk, stretch, or change posture, because these patterns remain deeply familiar within its structure. Across countless generations, motion formed the quiet background of human existence. Even today, beneath the stillness of modern environments, the human body continues to carry the memory of that moving world. As people gradually became more aware of how modern environments influence the body, a quiet shift in perspective began to appear. Scientists, physicians, and researchers studying human movement started examining the relationship between daily habits and the biological systems that support posture, circulation, and balance. Their observations often returned to the same simple idea. The human body responds well when movement appears regularly throughout the day. Not necessarily intense activity, but gentle variations in posture and motion that allow the body's joints, muscles, and internal systems to function within the patterns shaped by long evolutionary history. In recent decades, studies of daily activity have begun measuring how much time people spend sitting during work, travel, and leisure. These studies have shown that many individuals in modern societies remain seated for long intervals, sometimes several hours at a time. Yet researchers have also observed that even brief moments of movement can change how the body responds to stillness. Standing for a few minutes, walking across a room, or shifting posture during work can reactivate the muscles that support balance and circulation. These movements are small, yet they reconnect the body with patterns that once appeared naturally throughout daily life. In response to this growing awareness, some workplaces and institutions have begun experimenting with ways to reintroduce movement into environments that were originally designed for prolonged sitting. Standing desks have appeared in offices where workers can alternate between sitting and standing during the day. Some organizations encourage walking meetings, allowing conversations to occur while participants move through outdoor spaces. Schools and universities sometimes design classrooms where students can change posture more freely rather than remaining seated for long periods. These adjustments are not attempts to reject the tools of modern life. Instead, they represent small efforts to balance comfort and efficiency with the biological needs of the body. Technology itself has also begun adapting to this awareness. Devices that track daily movement now remind people to stand, stretch, or walk briefly after periods of inactivity. These reminders may seem simple, yet they reflect an understanding that the body benefits from periodic motion even during otherwise sedentary routines. The goal of these systems is not to transform modern life into something resembling the distant past. Rather, they acknowledge that the human body still carries the biological expectations formed during thousands of generations of movement across natural environments. Anthropologists often note that human adaptability has always depended on the ability to adjust environments in response to new challenges. Early humans shaped stone tools to improve hunting and gathering. Later societies built irrigation systems to support agriculture. In each case, people modified their surroundings to support the needs of the human body and community. The modern interest in reintroducing movement into daily routines reflects a similar form of adaptation. Instead of abandoning the conveniences of technology, people are learning how to design environments that leave space for motion within a world increasingly organized around seated work. What makes this moment particularly interesting is that the solution does not require dramatic changes. The body does not demand constant exertion or intense physical effort. It simply responds well when posture and movement vary gently across time. A few minutes of walking between tasks, standing during a conversation, or stretching after sitting can restore the quiet rhythm of motion that once appeared naturally in earlier environments. These small adjustments reconnect modern life with the deeper patterns that shape the human body over immense spans of time. As this awareness continues to grow, it suggests that the relationship between humans and their environments remains dynamic. The tools and spaces people create will continue to evolve, just as they always have. Within that process of change lies the possibility of designing environments that remember the body's long history of movement while still embracing the knowledge and technology of the modern world. As the long journey of the human body comes into focus, a quiet realization begins to emerge. For nearly all of our species' existence, the body moved through landscapes that required constant adjustment. The ground changed beneath the feet, the horizon shifted as people traveled, and daily survival depended on the ability to walk, carry, bend, and rise again. Motion was not something people scheduled into their day, it simply surrounded them. The human body, therefore, grew within a world where posture rarely remained the same for long. Balance, circulation, and strength quietly developed within this moving environment. Then, within a very short moment in the long story of humanity, the environment changed. Villages became cities, tools became machines, and information began flowing through invisible networks of communication. Chairs, desks, vehicles, and screens created a world where the body could remain still while the mind traveled across enormous distances of knowledge and connection. This transformation allowed humans to build societies of extraordinary complexity. Ideas could be recorded, shared, and expanded in ways that earlier generations could hardly imagine. The modern world became a place where the mind could move rapidly, even when the body remained seated. Yet beneath these achievements, the structure of the human body has remained largely the same. The bones of the legs still carry the design of long-distance walkers. The hips still rotate in ways that allow the body to lower toward the ground. The muscles that surround the spine still respond to gravity as they did thousands of generations ago. The circulatory system still benefits from the gentle assistance of moving legs and shifting posture. In quiet ways, the body continues to remember the conditions under which it first developed. This does not mean that sitting itself is wrong. Humans have always rested, paused, and gathered in places where movement slowed for a time. What seems to matter more is the balance between stillness and motion. When the body remains in one posture for too long, movement often brings a sense of relief. A short walk across a room, a stretch of the legs, or a change in posture can feel surprisingly natural. These simple moments remind us that motion has always been part of how the human body functions. The story of sitting, therefore, is not only about chairs or desks, it is about the relationship between the environments we create and the bodies that inhabit them. Humans have always shaped the world around them, building tools and spaces that reflect their needs, knowledge, and creativity. At the same time, the body continues to carry traces of a much older world, one where movement was woven into every part of life. Perhaps the most interesting question is not whether humans were designed for sitting. The deeper question may be how the modern world will continue to adapt to the body that built it. As technology grows more powerful and environments become more controlled, will daily life leave room for the quiet movements that once defined human existence? Or will future generations discover new ways to bring motion back into the spaces where people now spend so much of their time? And perhaps there is an even simpler question worth wondering about tonight. When you stand up from your chair and take a few steps across the room, does your body feel as if it is returning to something familiar? Does that small movement feel strangely natural, as if the body remembers a rhythm far older than the buildings around us? If the human body truly evolved in motion, what do you think it might be quietly asking from the environments we build today?